Good evening, everyone. Can you all hear me? Please respond. Am I audible to all of you? All right, great. So let's start the today's session. We'll be starting with the probability. All right. Now, probability, if you look at the CAT papers, so I have never seen any questions except in 1993. In 1993, I saw one question based on probability, and that was very easy. Okay, that's it. But yes, in other examinations, probability do come. For example, in the examinations like XAT, in the XAT, you can get a set of 3 to 4 questions of probability in the decision making section. Okay. Over the years, if you refer to the past year papers of the XAT, especially the decision making section, so at times they ask a question based on the probability, a set of 3 to 4 questions on the probability. So you should know all the basic concepts of probability. As well as in IFT also probability is common. You'll get around 1 or 2 questions in IFT, SNAP also. Everywhere you'll find out probability, 1 or 2 questions, not very much. So can I move to the, and it's a very easy topic, it's not a difficult one. Can I move to the next slide? Please tell me. Okay. The first thing which we'll talk about is the introduction to probability. Okay. Now, when I'm saying the introduction to probability, let's say if I say there is a coin, and on the coin there is a one side is head and the other side is tail, and we know that if we throw a coin, the probability of getting head is half, as well as probability of getting a tail is also half. So, or we can say that there is a equal chances of getting head and as well as equal chances of getting tail also. All right. So how do I define probability? So I can say suppose we have a coin where one side is head and the other side is tail. If we flip the coin over and over again, we expect the proportion of flips that come up heads to be roughly 1/2. So we say that the probability that a coin flip will turn up head is 1/2. This is probability. So probability, what I say that probability is nothing but it is simply a ratio of 2 terms. Okay, numerator upon denominator. So for finding the numerator or finding the denominator, you should know the basic concepts of permutation and combinations, as well as algebra, as well as geometry also. So this is probability, the proportion of times that we expect an outcome to occur if we perform the experiment over and over. Now notice that we can't say the exact proportion of times we have success. This is the difficulty in defining probability. Probability only exists because we are trying to measure an event which is not a definite, which is not a fixed here. In our coin example, there are 2 equally likely outcomes. Now, this is very important that whenever we find out the probability, we need to find out that all the outcomes has equal chances, 2 equally outcomes. Heads and tails. One of these outcome is head, so we exact the proportion of the head to be half here. This is in general how we approach many probability problems. We figure out how many equally likely outcomes are there. So I'll keep focusing equally likely outcomes, that is important here. And then count how many of these outcomes are what we call the success. So our probability is the ratio of the number of successful outcomes to the total number of possible outcomes. But we have a very important consideration, and what is that? That each outcome must be equally likely. So can I move to the next slide now? Please tell me. All right. Let's start with a very basic example. The faces of a pair 6-sided die are numbered from 1 to 6. What is the probability that when it is rolled, a 2 is facing up? Very simple question, 1/6. Now this term is important, the fair. Okay, fair dice. So fair dice means all the dice has got equal chances. It is not a dice of Sakuni Mama. All right. So a fair dice means everything has got a equal chances. Okay, every number has got an equal chances here. So I can say if I'm throwing a dice, there is an equal chance of getting 1, equal chance of getting 2, equal chance of getting 3 or 4 or 5 or 6. So probability is nothing but 1/6 because I need to find out probability of getting 2. So out of 6 cases, in 1 cases I am getting 2, so it is 1/6. All right. Now, so if all the outcomes are equally likely, then probability of success is simply equal to number of successful outcomes upon number of possible. Now, to find the number of successful outcomes as well as number of possible outcomes, it would be good in what? Can you tell me which concept topic में strong होना चाहिए? Which topic it should be strong enough? That is permutation and combination. We need to find out, okay, permutation combination in general, or not even permutation combination, in some of the cases, geometric probability, algebra also. Alright. Now, so tell me, a very easy one. What is the probability that when a fair six-sided die is rolled, a prime number faces up? Okay. So when I say six-sided, so the possibility is 1, 2, 3, 4, 5, 6. These are the six possible outcomes. And out of these six outcomes, in three of the cases, we are getting prime 2, 3, and 5. So the probability is nothing but that is 3 by 6, which is equal to half. And that is the answer. So can I move to the next slide? Please tell me. Now, another thing is when working on a probability problem, okay, whenever you are working on a probability problem, if you ever get a probability that's less than 0 or greater than 1, you have made a mistake. The probability will always be in the range 0 to 1. Okay, so while solving the questions, if you are getting something which is more than 0 or sorry, more than 1 or less than 0, it means there is something which you have done it wrong here. Okay, so probability will always lies in the range 0 to 1. Can I move to the next slide? All right, now try this. A standard deck of 52 cards is divided into 4 suits. Each of the suit has 13 cards. Two of the suits are called heart and diamond, and the are red, and the other two are called spade and club, are black. The cards in the deck are placed in random order. Now, always remember, it's not necessary that in the exam the definition of the suit will be defined. You should know these. Okay. So Bhaskar is saying 1 by 2. Avinash is saying something else. Okay, we'll see that. It says a standard deck of card has 52 cards divided into 4 suits. Each of which has 13 cards. Two of these suits are there. It says the cards in the deck are placed in a random order. What is the probability that the first two cards are red? Now, first of all, if I'm picking two cards, what is the number of possible outcomes? What is the total number of possible outcomes? Can you say the total number of possible outcomes? The first card, it can be of any of the 52 cards. Yes or no? The first card, it can be any of the 52 cards. So the second card, it can be from the any of the 51. So can you say the total number of possible outcomes? It is 52 into 51. Because I'm talking about the first card. So if I pick the first card from the top, if I'm picking the first card from the top, so it can be any of the 52. And then I'm picking the next card. So it can be from the any of the remaining 51. So 52 into 51. And what is the possible number of possible or simply the number of successful outcome? Number of successful outcome. The question is that what is the probability that first two cards are red? So that the first card is red. It can be any of the 26 cards because 26 cards are red and 26 are blue. So I can say any of the 26 cards, and the second card is also red. That is 26 into 25. So the probability it is equal to 26 into 25 upon 52 into 51, which will be comes out to be 25 by 102, and that is the answer. Any doubts to anyone now? Please tell me. So is that clear? Can I move to the next slide? All right. Now, next thing which we'll talk about is equally likely outcomes. Okay, let's start with an example here. We have a cube with 4 blue faces and 2 red faces. What is the probability that when it is rolled, a blue face will be facing up? That's right. So I can say there are 4 blue faces and there are 2 red faces. So the probability is nothing but that is simply equal to 4 by 6, which is equal to 2 by 3. Okay, I can say for each face there is an equal chances. Okay, the first blue face has got equal chances. Second blue face has also got an equal chances. Third blue face has also equal chances. So each of the faces has got an equal chances. That is of 1 by 6, 1 by 1 by 6. So the answer is 4 by 6, which is 2 by 3. Can I move to the next slide? Okay, try this. Suppose we have two pairs six-sided dice numbered from 1 to 6. If we roll them both, what is the probability that the two numbers shown sum to 7? The sum of the two numbers is 7. Okay. Avinash is saying 1 by 6. Now just here. First of all, tell me what is the number of possible outcomes? Number of possible outcomes, that is equal to 6 into 6, which is equal to 36. First dice, it can show any of the 6 numbers. Second dice can also say any of the 6 numbers. So that is 36. And if the first dice is showing A, the second dice is showing B, but the sum of these two numbers must be equal to 7. So what are the possibilities? I can say 1, 6, 2, 5, 3, 4, 4, 3, and 5, 2, and then 6, 1. Okay. So I can simply say that the probability it is equal to nothing but 6 by 36, which is equal to 1 by 6. And that is the answer. Any doubt? Now, another thing which is also very important in case of a dice, if I'm talking about the sum and the number of ways. So, sum 2, what is the total number of ways in which I can get a sum of 2? There is exactly one way, 1 plus 1, 2. For sum 3, there are two ways. Yes or no? Always less than 1. 4, there are three ways. That is 1 plus 3, 2 plus 2, and 3 plus 1. For getting a sum of 5, it is nothing but that is 4 ways. Okay. For getting a sum of 6, there is a 5 ways. Also remember, the number of ways in which I am getting the minimum possible sum is 2. What is the maximum possible sum on 2 dice? Can I say 12? So to get a sum of 12, again there is only one possibility, that is 6 plus 6. So for minimum possible sum and the maximum possible sum, the number of favorable cases always same, that is 1. Similarly, the number of ways to getting a sum of 3 and 11, it is going to be exactly same. 11 also, I can say 6 plus 5 and 5 plus 6. Only 2 ways. Same thing, 4 and 10, there are 3 ways. And 5 and 9, that means 4 ways. And 6 and 8, 5 ways. And getting a sum of 7, that is 6 ways. Okay? This is the pattern which we'll get here. And now, which is the sum which you are getting maximum number of times? Which is the sum which you are getting maximum number of times? Please tell me. 7. So the sum which has got a which is repeating maximum number of times, that particular sum is known as the most probable sum. Or if I ask you which is the most probable sum here, so 7, there is a maximum chances of getting a sum 7 in 6 of the cases here. So 7 is known as the most probable sum. All right. So can I move to the next line now? Okay. Now, try this. Suppose two distinct integers are chosen between 1 and 9 inclusive. What is the probability that they are both odd? Tell me. What is the probability that they are both odd? Okay, now let's try to understand to method 1 and then method 2. Now, in the method 1, there are two different thought processes here. Okay. If I say the order is important, the order in which I'm selecting the number is important, or order is, I'll say, let's say, not important at all. Okay, so I can say in this case the probability is what? Out of 9 numbers, I am selecting 2 numbers. How many ways? That is 9C2. Okay. And we need that both the numbers are odd. So from 1 to 9, there are 5 numbers which are odd. So out of 5 numbers, the 2 numbers can be selected in how many ways? 5C2. And what is 5C2 upon 9C2? 5C2 is equal to 10, 9C2 is equal to 36. So 10 by 36, which is equal to 5 by 18. And that is the answer. If order is not important, so I'm simply picking the 2 numbers. Is that clear to all of you? Please respond. Second, if I say order is important, order is important. Like in one of the questions earlier, question number 3, we have seen that case. Probability. There are 10 numbers. So the first number, it can be any of the 10 numbers in 10 different ways. Okay, sorry, 9 numbers. So first number, it can be selected from any of the 9 numbers. Second number, I can select from the remaining 8. So 9 into 8. This is the number of possible outcomes, successful outcomes. There are 5 odd numbers. So the first odd number, it can be selected in how many ways? That is 5. And the second in 4 ways. So 5 into 4, that is equal to 20 upon 72, which is again 5 by 18. So always remember, in case of probability, it doesn't matter. Okay. The only thing is that you need to remember that probability is the ratio of two numbers. If in the numerator, if you are trying to find out the numerator by using the selection, then the denominator also you try to find out by selection, where the order is not important. And in the numerator, if you are doing the arrangement, then in the denominator also you should do the arrangement. But if you are making a mistake, like in the denominator you are doing arrangement, in the in the denominator you are making arrangement, in the numerator you are making selections, then you'll get wrong. So make sure whenever you are doing the any question based on the probability, if in the numerator you are taking order is important, then the denominator should also you should take care of that order is, or in both the cases, numerator and denominator you should take that order is not important. You'll always get a correct answer. How do you calculate 5C2? Since we have solved so many questions, so I know that it is 10. NC2 is always equal to n into n minus 1 by 2. Most of the time we encounter the term NC2. So NC2 is always equal to n into n minus 1 by 2. No? So that is 5 into 4 is 20, 20 by 2. Remember, most of the questions you'll come across this only. That is NC2. That's a very common thing. No? So NC2 is always equal to n into n minus 1 by 2. You can use it directly. Okay. So can I move to the next slide? Guys, please tell me. Now, in a single throw of 5 dice, which is the most probable sum? In a single throw of 5 dice, which is the most probable sum? 7. Okay. All right. Now I am throwing 5 dice. Okay. If I'm throwing 5 dice, what is the minimum possible sum which I'll get here? What is the minimum possible sum? Tell me, all of you. That is 5. And what is the maximum possible sum? What is the maximum possible sum? If I'm throwing 5 dice, that is 30. So the total number of ways in which I can get a 5 or 30, that is always going to be 1. Yes or no? Similarly, next sum is 6 and 29. So the number of ways to get a sum of 6 and 29, let's say that is x. For both of them will be equal. How many cases are there? We do not know. I'll say let's say x cases. Similarly, the number of ways to get a sum 7 and 28, that is always equal to y. So what is the sum of these two numbers? That is 5 plus 30, 35. 6 plus 29, 35. 7 plus 28, 35. Yes or no? Then I'll get 8 plus 27, that is 35, and so on. In the last, can I say I'll get 17 and 18 plus 35. So which is the most probable sum? There are two possible answers. So 17 and 18. So the most favorable sum, most favorable or most probable sum is nothing but that is 17 and 18, which is always the average of minimum and maximum. For example, in the case of 2 dice, the minimum was 2, maximum was 12. So 2 plus 12 by 2, which is equal to 7. The middle value. The most probable sum is always the median. Okay. So if there are 2 dice, the median was 7. But here there are 5 dice. So the median here is nothing but that is 5 plus 30 by 2, which is equal to 17.5. So I'm getting 17.5. So the most probable sum will be 17 and 18. And this is the answer. Any doubts to anyone now? Please respond. So can I move to the next question then? How can we maximum with 60? On any dice, maximum 6 will come. And if there are 5 dice, so maximum I'll get 5 into 6, 30. 60 कहाँ से आया 5? Please tell me. Maximum you can get 30. So can I move to the next slide, guys, now? Okay. Now try this. In a single throw of 7 dice, what is the probability of getting a sum of at least 25? In a single throw of 7 die, what is the probability of getting a sum of at least 25? I need to find out the probability, not the most probable sum, right? What is the minimum possible sum I'll get? Please tell me. If I'm throwing 7 dice, 7. And what is the maximum sum? That is 42. And how many ways? Let's say the total number of ways is x. I do not know what is that. To get a sum of 8 and 41, that is y. To get a sum of 9 and 40, that is equal to z, and so on. And what is the average of 7 and 42? What is the most probable sum? 7 plus 42 by 2, I'm getting 24.5. So I'll say it will goes like 24 and 25. Okay. Now if I say the total number of ways in which I can get the sum from 7 to 24, if it is equal to k. Okay. The total number of ways for this number, it is equal to k. Okay. If I say number of ways is equal to k. So what is the total number of ways to get a sum of from 25 to 42? Is it going to be more than k or less than k, or it is exactly equal to k? It is exactly equal to k. Because the number of ways for getting a first half, it is going to be exactly equal to the for the second half. So the number of ways in the second case is also equal to k. Yes or no? Number of ways for getting k. So I can say, I can write it down also, the number of ways to get sum of 7 to 24, it is exactly equal to the number of ways to get sum of 25 to 42. So tell me now, what is the answer? What is the probability of sum of at least 25? Tell me. That is going to be equal to half, and this is the answer. So any doubts to anyone? So can we move to the next slide? Please respond. Okay, number of ways to get a sum of 7 to 24, it is exactly equal to the number of ways from 25 to 42. See, both of them are equal. So the probability of getting the sum from 7 to 24, it is equal to probability of getting from 25 to 42. So that is half. Equal chances are there. So can I move to the next slide now? A warning. Sir, for sum for at least 23. Okay. For at least 23, if I'm getting such type of the questions, I'll prefer. What should we do? Please tell me, rest of you. If the question asked is that sum of getting at least 23, so what should we do? Anyone who can tell me? नहीं, क्या करना चाहिए? Yes, question छोड़ दो, leave the question. It's not necessary to attempt it ना. ऐसा नहीं है कि we can't do it. Then we can find out how many ways I can get the sum of 23, sum of 24, sum of 25, 26 for each of them. Like A plus B plus C plus D is equal to 23. What is the total number of cases? Or A plus B plus C plus D is equal to 24. How many cases are there? So solve it by using permutation and combination and count it. So definitely we can do that, but that's not needed. Can I move to the next slide? Is that clear now? Faster? Okay. You won't get a question which is not doable in 1 or 2 minutes or maximum of 3 minutes. Okay. Now, next part, don't compare apples to oranges. Or, like I told you earlier, however you choose to determine your outcome, make sure that you use a consistent approach for counting both the total number of outcomes and the number of successful. If you count the total outcomes when order matters, then you need to count the successful outcomes when order matters. Similarly, if you count the total outcomes without regard to order, then you need to count the successful outcome also without regard to order. You'll always get the same answer. All right. Now, next part it is counting technique in probability problems. Try this. 10 people are sitting around a round table. 3 of them are chosen at a random to give a presentation. What is the probability that the 3 chosen people were sitting in consecutive seats? Please tell me your answer. Okay. Now, first of all, tell me what is the number of possible outcomes? What is the total number of possible outcomes? Out of 10 people, we need to select 3 people. So, out of 10, 3 people can be selected in 10 seats. Now, number of successful outcome. Okay. 3 of them are chosen at random to given a present. What is the probability that the 3 chosen people were sitting in column? I'll say select one person. Okay. Select any person. Select any middle person. Okay. So out of 10 people, so if the 10 people are sitting across a circle, let me represent it here. If there are 10 people sitting across a table, if I say person number 1, person number 2, person number 3, person number 4, 5, 6, 7, 8, 9, and 10. So select any person. Let's say I select any one person. The first person, it can be selected in how many ways? Any of the 10 different ways, isn't it? The first person, it can be selected in 10 different ways. And once I select that person, so the next two person, it has got only one and one ways, because it says that all the 3 persons were sitting in the consecutive. So if I pick any one person, the first person can be selected in 10 ways. So the next two person, we have got only one possibility. I need to select 5 and I need to select 7. So what is the probability? Probability is nothing but that is 10 upon 10C3. Okay. So 10 upon 10C3. So 10 upon 10C3, 10 into 9 into 8 by 6, which is 120. So the answer is 1 by 12. Any doubts to anyone? Please tell me. Can I move to the next slide? So when I say counting techniques, so all the funda of permutation and combination we can use here. All the question of P and C, which whatever we have discussed, it can be converted into probability questions. Now, try question number 10. Two different two-digit numbers are randomly chosen and multiplied together. What is the probability that the resulting product is an even number? Two by three. Okay, we'll check that. First of all, how many two-digit numbers are there? Can anyone tell me how many two-digit numbers are there? 10, 11, 12, 13, and so on till 97, 98, and 99. So how many two-digit numbers are there? 90. Okay, there are 90 values. Okay, so now probability, it is equal to, out of 90 numbers, 2 numbers are selected. So out of 90 numbers, 2 numbers can be selected in how many ways? 90C2. So in the denominator, the total number of possible outcome is 90C. But the product of those two numbers is even. So tell me one thing. What are the different possibilities? Either both the numbers are even, or one number is even, other one is odd, or one number is odd, other one is even, or both of them are odd. Now, out of these four cases, in the first three cases, the product is always going to be even. And in the last case, the product is going to be odd. So which one is easier to do? Finding the answers for the first three cases, or from total subtract the last case? Tell me. Which one is easy? From the total subtract the last. So out of 90 numbers, two of the numbers can be selected in 90C2 is minus. And whenever the two selected numbers are odd, the product is always odd. And out of these 90 numbers, can you say there are 45 odd numbers? So minus 45C2. So out of 45 odd numbers, two odd numbers can be selected. So in the rest of the cases, automatically the product is even. Okay. So solve this, you'll get the answer. I think the final answer will be comes out to be 67 upon 89. That will be the answer. Any doubts to anyone now? Please tell me. So can we do like selecting each digit? There are 45 odd numbers, right? There are 45 odd numbers from 10 to 99, total 90 numbers. So 45 of them are odd, 45 of them are even. So when I selected number, both the number are odd, the product will be odd, but we need even. So 45C2 is subtracted. Can we do by selecting each digit? Yes, you can do it by selecting each digit. Here what I have done, ये तो selection ही किया है ना जतिन. When I say 90C2, so we are selecting the digit only. We are not doing anything else. We are not arranging the number. We are simply selecting the two digits. So any doubt? Can I move to the next slide? Please tell me. All right. Try this. Question number 11. टेंथ यार मुझे 90 नंबर में से दो नंबर सेलेक्ट करना है तो ये टेंथ प्लेस और यूनिट प्लेस कैसे कर सकते हैं बताओ मुझे जतिन. What is the question? I need to select two digit number. तो इसमें टेंथ प्लेस यूनिट प्लेस do I need to form a two digit number? I need to select two digit number. तो टेंथ प्लेस यूनिट प्लेस कैसे कर सकते हैं इसमें? Your entire thought process is wrong. Now guys tell me. We have a standard deck of 52 cards. All right. As in question number 3, with 4 cards in each of 13 ranks. We call a 5-card poker hand a full house if the hand has 3 cards of one rank and 2 cards of another rank, like triple three and double five or triple A double K. What is the probability that the 5 cards chosen at random forms a full house? Anyone? Okay. Probability, it is equal to. Now, what is the total number of favorable cases? So, possible outcomes. What is the total number of possible outcomes? Can anyone tell me? That's right, 52C5. Out of 52 cards, 5 cards can be selected in 52C5. Denominator is very easy to find out, isn't it? Now, under the condition, what is the probability that the 5 cards chosen at random from a full house? We need a full house. All right. So, tell me now. Now, can you tell me one thing here? We know these are the cards A, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. And how many different suits are there? There are 4 different suits. Yes or no? we're getting 4 sources. There are 4 categories. Yes or no? That is spade. Or I can say there are 4 sources instead of writing here. So first of all, I'll pick any one card. It can be either A or 2 or 3. So out of these 13 numbers, think it as 13 numbers, one of the number can be selected in how many ways? Out of these 13 numbers, one of the numbers can be selected in how many ways? That is 13C1. Okay. And for that particular number, I need 3 cards. Yes or no? For that particular number, we need 3 cards. Like say 13C1, if I pick A. So we need 3 that we are picking A. Okay. But for that particular A, we need exactly 3 cards. Exactly 3 cards. And there are 4 A's. So out of the 4 A's, 3 A's can be selected in how many ways? That is 4C3. Is that clear to all of you? Please tell me yes or no. So for example, let's say out of the 13 cards, I picked A or any of the 13 cards. But that particular card, it must be from 3 different suits. So out of 4 suits, 3 suits here. Into. Now I need to pick the second card. So the second card has got how many possibilities? 12C1. From the remaining 12 numbers, I need to pick one more number. Let's say I pick 10. So we have got 3 A's. Now I say that I'll pick 10. So from the remaining 12 number, I picked one number, that is 12C1. Okay. But for that particular number, we need how many cards? 2 cards or 3 cards? For that particular number, we need how many cards? Like I need how many tens? 2 tens. But we have got 4 tens. So out of the 4 different 10, we need only 2 of the 10. So into 4C. And this is the answer. If we solve this, we'll get the answer as 6 upon 4165. This will be the final answer. Any doubts to anyone now? Please respond. So can I move to the next slide? Siddhant, Aditi, Anupam, Avinash, Bhaskar, Bhumika, everyone. All right, guys. So let's move to the next question. Okay. Now, many probability problems are just 2 counting problems. So it's based on PNC, counting techniques. Counting the number of total outcomes and counting the number of successful outcomes. And for getting both, you should be strong in PNC also. Try this. In a single throw of 4 die, what is the probability of getting a sum of 15? Okay. Now, no. And there are 4 dice. All right. So I'll say, let's say the first dice, second dice, third dice, and the fourth dice. Okay. The first dice is showing on first dice, I'm getting the number A. Second dice, I'm getting number B. Third dice, I'm getting number C. And the fourth dice, I'm getting D. But the sum of these 4 numbers, A plus B plus C plus D, it has to be exactly equal to 15. And A, B, C, and D, it is lying in the range 1 to 6. On any dice, we'll get a minimum of 1 and a maximum of 6. And like I told you, most of the probability questions are based on the counting. So this is a question which we have done in the class, isn't it? In PNC, finding the integral solutions of this equation under this condition. Is that part clear to all of you? Till this step, please tell me. So I need to find out integral. So first of all, I'll take the reverse way. There are a lot of methods. Maximum upper limit is 6. So I'll write down A as equal to 6 minus X. B is equal to 6 minus Y. C is equal to 6 minus Z. And D is equal to 6 minus W. And that is equal to 50. And the value of X, Y, and Z and W, it will be in the range 0 to 5. Why? If X is 0, A is equal to 6. If X is 1, then A is equal to 5. The maximum value of X can be 5. Then in that case, A is 1. But can I take X as 6? No, because if I take X as 6, 6 minus 6 is 0, A equal to 0 is not possible here. Okay. So from here, I'll say that I'll get the equation X plus Y plus Z plus W, which is equal to 9. Now probability. Now, what is the total number of, okay, just tell me one thing first of all. What is the total number of solutions for this equation X plus Y plus Z plus W plus 9? Tell me. What is the total number of solutions? 12C3. That's right, 12C3. Any doubts? Sum of 4 variable is 9, so we need to do 3 partitions. So 9 plus 3 is 12, 12C3 minus. Subtract all the cases. We know inclusion, exclusion principle. But X greater than equal to 6 is not allowed. Maximum value of X is 5. But here, if I try to solve this equation, X can be 6 also, 7 also, 8 also, 9 also. So we need to subtract all those cases. So in how many of the cases can you guys tell me if X can be greater than equal to 6? I'll try to do it orally. In how many of the cases X is greater than equal to 6? Please tell me all of you. Or I'm writing down on the side, that is X plus Y plus Z plus W. Can you guys tell me X is greater than equal to 6? And for Y, Z and W, there is no restriction. Okay, how many solutions are there for this equation? Because that is not allowed. So 9 out of 9 chocolates, give 6 chocolates to X. We are left out with 3. So sum of 4 variable is 3. So 3 partitions, 6C, 3. And we will be getting 4 such cases. Isn't it 4 into 63? Because X is greater than equal to 6. Similarly, Y can be greater than equal to 6. Z can be also greater than equal to 6. W can be also greater than. So there will be 4 cases when X is greater than equal to 6. Y and Z and W. So there will be 4 cases. In each of the cases, we will be getting 63 possibilities. Minus 2 numbers are greater than equal to 6. Is that possible that 2 of the numbers are greater than equal to 6? No. So I'll get minus 0, then plus 0, minus 0. You all know this process. Upon, what is the number of successful outcomes? Tell me, what is the number of successful outcomes? 6 raised to power 4. Yes, for the first dice, it is showing 6 possibilities. Second dice has got 6 possibilities. Third dice, 6 possibilities. Fourth also 6 possibilities. So 6 raised to power 4. So what is the answer? That is 12C3 minus 4 into 6C3 upon 6 raised to power 4. And this is the final answer. Any doubts to anyone now? Please respond. So like I told you, all the questions which we have discussed in permutation and combination, it can be converted into the probability. That is just one of the example I have taken. Any doubts now? Please respond. No. So can I move to the next slide? Now, so next part is probability and addition. So targeting these probability systems is that is basically to tackle those traditional probability cases. So now we'll move to the probability and addition. Let's say when rolling a pair 6-sided die, what is the probability of a 2 or a probability of 4 is rolled? Tell me, all of you. What is the probability of getting 2 or 4? So now I'll go step by step to explain the funda of addition principle in probability. All right. So just here. First of all, can you say that is in the denominator? It is nothing but the number of possible roles. Okay. Now, in the numerator, it will be nothing but number of ways 2 or 4 can be rolled. Most of you have got the correct answer, but let's go step by step, which is equal to. So, number of ways in which 2 is rolled plus number of ways in which 4 is rolled, and then divided by. Now, divided by, I can say number of possible rolls. Okay. And number of ways, which I can write down step by step, number of ways in which 2 is rolled upon number of possible rolls. Okay. Plus number of ways to in which 4 is rolled upon number of possible rolls. So number of ways I am getting 2 upon number of possible rolls, it means that is probability of 2 upon probability of 4. And this is what it is, addition principle, probability of 2 or 4. So probability of getting 2, it is equal to 1 by 6, and probability of getting 4 is also 1 by 6. And 1 by 6 plus 1 by 6 is equal to 1 by 3. Any doubts to anyone now? Please respond. So can I say one important formula which is important here, that if there are 2 events A and B which are mutually exclusive, means that either A or B can occur but not both. The meaning of mutually exclusive is that the A intersection B, it is equal to 0. If A intersection B equal to 0, it means the events are mutually exclusive, which means there is nothing common. Like when I'm throwing a dice, getting a 2 and getting a 4, there is nothing common in that. So in that case, probability of A or B, it is always equal to probability of A plus probability of B. Or in general, if there are n events and all of them are mutually exclusive, it means the intersections of all these events is 0, then I can always say it is equal to probability of A1 plus probability of A2. So any doubts to anyone? Can I move to the next slide? What is the doubt in question number 12? Tell me, Siddhant. It's already taken care of now, Siddhant. When I have written A is equal to 6 minus x, so I say x, the minimum value of x can be 0 also. In that case, A is equal to 6. And maximum value of A is equal to 5. So already taken care of this. So that's why it is 0 to 5, not 0 to 6. Okay. Any other doubts to anyone now in question number 13 or the addition principle? No. Even if you take lower limit, still you will get the same answer. Okay. For if you take care of lower limit, then in that case, upper limit will become 5. Okay. And then again, if you take care of upper limit, you'll get the same answer. Alright. You'll never get a different answer. You must have done some calculus. Can I move to the psi? Even if I take the lower limit as 0, if you are taking care of lower limit in question number 12. So what is the lower limit? A is equal to 1 plus P. Okay, B is equal to 1 plus Q, and C is equal to 1 plus R. D is equal to 1 plus S, which is equal to 15. So I'll get P plus Q plus R plus S, that is equal to 15 minus 4, which is 11. But what is the range of PQRS? It is from 0 to 5. Okay, now reverse it again, then you will get the same equation. So in that case, the range of PQRS will be from 0 to 5, not from 0 to 6. Okay? Is that clear? Can I move to the next slide, please? Tell me. So it doesn't matter how you proceed, no? You'll always get the same answer. I have told, okay, you have got an equation that is equal to P plus Q plus R plus S, which is equal to 11, and the value of P, Q, R, S, it is lying in the range 0 to 5. Now I'll say P is equal to 5 minus X, Q is equal to 5 minus Y, and Z is, R is equal to 5 minus Z, and then it is equal to 5 minus W. it is equal to 11. So what is the value of x plus y plus z plus w? 5 4s are 20. 20 minus 11, that is 9. And what is the range of x, y, z, w? Again 0 to 5. So it doesn't matter how you proceed. If you are taking first care of lower limit, then upper limit, or if you are taking care of both of them simultaneously, you'll always get the same answer. Now, if I'm writing a is equal to 6 minus x, means the maximum possible. Okay, x a will always lie in the range 1 to 6. So what is the possible value of x? Minimum possible value of x is 0. In that case, a is 6, and the maximum possible value of x is 5. In that case, a is 1. So x, y, z, and w, they are all lying in the range 0 to 5. Okay. Can I take x equal to 6? No, because if I take x equal to 6, a will be 0, but a can't be 0. So the maximum value of x is equal to 5. Clear now? So it doesn't matter. किसी भी तरीके से equations को, you'll always get the same answer. As the lower and upper limit of all the 4 variables are same, so there is no need to make 2 different cases. If there is a lower limit and the upper limit is also keeps on changing, then first you need to make sure lower limit of all of them is 0, and then you need to proceed. But here, for all the 4 variables, it is exactly same. So it doesn't matter at all. Can I move to the next slide now? And I have shown it to you, get the same equation. All right, let's now try this question number 14. A fair coin is flipped 7 times. What is the probability that at least 5 of the flip comes up head? Anyone? No. At least 5. So it says that probability of at least 5. Probability of at least 5 head. So can you say probability of at least 5 head? It is equal to probability of getting 5 head, or probability of getting exactly 6 head, or probability of getting 7 head. Any other possibilities? Please tell me. No. So if I'm getting 5 heads, so out of these 7, on 5 of the cases I'm getting head, so 7C5 upon 2 raised to power 7. Probability of getting 6 heads, so that is 7C6. On which 6 we are getting head, so 7C6 upon 2 raised to power 7, and 7 head, that is 7C7 upon 2 raised to power 7. And this is the answer. In fact, if you solve this, I'm writing the final answer. It will be 29 by 128. Any doubts to anyone now? Can I move to the next slide? Please respond. Try this. A coin is flipped 10 times. Yes, that's it. What is the probability at least 6? So at least 6, I can say 10C6 plus 10C7 plus 10C8 plus 10C9 plus 10C10 upon 2 raised to power 10. Now the basic purpose of giving this question was that, just to revise one of the important concepts, we all know that is 10C0 plus 10C1 up 10. Worst term, that is 10C10. What is this value? 2 raised to power 10. Yes or no? And there are 11 terms. There are 11 terms. So, and I need to find out the sum of the last 5 terms. That is 10C6 plus 10C7 plus 10C8 plus 10C9 plus 10C10. So can you say 2 raised to power 10 minus the middle term, that is equal to 10C5 and divided by 2? यही होगा ना? Please tell me yes or no. Okay. because there are 11 terms, so sum of first 5 terms and the sum of last 5 terms, they are equal. So subtract first of all the middle term, that is 10c5, and the sum for first and last is equal, so I'll divide this by 2. So I can say, solving this equation, you will get 2 raised to the power 10 minus 10c5 upon 2 into 2 raised to the power 10, and this. Just keep this thing in mind. Sometimes the options can be in this. Any doubts to anyone? All right. Try this. Try this. A card is chosen at random from a standard deck of 52 cards. What is the probability that the card is a queen or heart or both? All right, now just see it here, all of you, step by step. What is the number of ways to choose queen? What is the total number of ways to choose the queen? There are 4 ways. There are 4 queens, so 4 ways. Similarly, number of ways to choose heart. There are 13 heart. So I can say there are 13 cards of heart, that is 13. So what is the number of possible outcomes? Number of possible outcomes. Can I say that is equal to 4 plus 13 minus 1, which is equal to 16. Why? Because we will be one card which is a common also. Now, first of all, remember there is a one card which is common, that is the queen as well as heart. Can I say these two events, events are not a mutually exclusive events? Not a mutually exclusive events. Okay, not a mutually exclusive events. Why? Because mutually exclusive events, that is only possible if the intersection, if there is nothing common. But here there is a one card which is common to both of them, so this is not a mutually exclusive event. So probability in any case, you can say there are 16 possible, 16 by 52, which is equal to 4 by 30. Any doubts to anyone now? Please respond. Now, so I can say that the probability of getting a queen or heart, that is equal to probability of getting a queen plus probability of getting a heart minus probability of queen of heart, because there is a one queen which is of heart, so you can say 4 plus 13 minus 1. So the probability of getting a queen, that is 4 by 52. Probability of getting a heart, that is 13 by 52. And a queen of heart, that is 1 by 52. 1 by 52. So this will be comes out to be 4 by 30, and that is the answer. So any doubts to anyone now? Please tell me yes or no. हाँ, both also का मतलब क्या होता है बताओगे मुझे? What is the probability that the card is the queen or heart? Or both means what? It can be what? Queen of heart also. That is the meaning of the term both. So that I have already taken care now. I can't make the same cases 2 times. When I am selecting a king or I am selecting a heart, so this same case it has been. क्योंकि tell me one thing, Garima, when I selected a queen, तो इस queen में heart का भी तो queen आ सकता है ना? And when I have selected heart, so there is a one card which is common to both of them, isn't it? Okay, if there are queen, so अगर queen tell, okay, what are the queen? There is a one card which is a queen of heart also, so that's a queen of heart happening. I have written queen of heart. There is a one card which will be queen as well as it is of heart also. So I need to take care of that. It has been counted twice. Is that clear to all of you now? Please respond. Okay. So what I can say here, this is not a mutually exclusive event. So I can say, make sure your outcomes are mutually exclusive. If not, you'll have to correct for the overcounting of the cases which are in more than one. So in particular, if A and B are two events, then probability of A or B is equal to probability of A plus B minus probability of A intersection B. And for mutually exclusive events, okay, now for mutually exclusive events, okay, the A intersection B, that is always equal to 0. So you need to make sure whenever you are solving question whether the events are mutually exclusive or not when you are applying addition test. Is that clear? Can I move to the next slide? Try this. A bag has 3 red and K white marbles, where K is a positivity. Two of the marbles are chosen at random from the bag. Given that the probability that the two marbles are of the same color is half, find the K. So can you say it will be like this one? Probability that both the marbles are of the same color. So what is the probability? The probability that both are red or probability that both are white. यही possibilities होगी. Any other possibilities? Please tell me, all of you. Am I audible? So probability that both of them are of the same color, that is half, is equal to both are red. So that is 3C2. There are 3 reds, so 3C2, and total is 3 plus KC2 plus probability that both are white. Out of K cards, 2 of them are white. So that is KC2 upon 3 plus KC2. So the denominator, it will be equal to 3 plus K into 2 plus K by 2. वो numerator में चला जाएगा, and 3C2 is equal to 3 and KC2, that is equal to K into K minus 1 by 2, and this is equal to half. So if you solve this, you'll get a quadratic equation and you'll get the value of K is equal to 6 or 1. Yes, that's right. This is the answer. हो जाएगा? You all can solve this equation. Please tell me yes or no. Yes. I can move to the next question then. So should I move to the next slide? All right. Now next part is complementary probabilities. Okay, complementary probabilities. Now if I ask a question, what is the probability it will rain tomorrow plus probability it will not rain tomorrow? Can anyone tell me what is this value equal to? It is always equal to what? या तो बारिश होगी या नहीं होगी. Okay. So can I say that the probability that A does not occur, it is always equal to 1 minus probability that A occurs. If one thing is happening, either it is happening or it is not happening, and the sum of their probability is always 1. So the probability of A does not occur is always equal to 1 minus probability of A occur, and that is known as the complementary probability. Can I move to the next slide? Tell me this. What is the probability that when we roll 4 fair six-sided dice, they won't all show the same number? No. Now, first of all, what is the probability that all are showing same number? All are showing same number. Can anyone tell me? Can I say that is equal to 6 upon 6 is to power 4? Okay. All are showing same number. There are 6 possibilities. Either all of them are showing 1, or all of them are showing 2, or all of them are showing 3, or 4, or 5, or 6. Okay. So, probability that 4 dice all won't show the same number. All won't show the same number. That is going to be equal to what? 1 minus 6 upon 6 is to power 4. So, that will be equal to 215 by 216. That is the answer. Any doubts to anyone now? Please respond. यही आएगा और something else I'll get. I think you'll get 215 by 216. All right. Now let's move to the next slide. Okay, let's see it. 15 by 21. Yes, that's right. Nitin and Rahul each sit in a row of 7 chairs. So there are 7 chairs: 1, 2, 3, 4, 5, 6, 7. They choose their seats at random. What is the probability that they don't sit next to each other? Now, can you guys tell me probability that they sit next to each other? Next to each other. So out of these 7 seats, we need to select 2 seats for Nitin and Rahul. Yes or no? So out of 7 seats, the 2 seats for Nitin and Rahul, it can be selected in 7C2. But in how many of the cases they are sitting next to each other? Can you say they can sit next to each other either in the seat number 1, 2, or 2, 3, or 3, 4, or 4, 5, or 5, 6, or 6, 7? So the number of ways in which I can select 2 seats for Nitin and Rahul is 7C2. And out of these many cases, only in 6 of the cases, they are sitting next to each other. So this is equal to 2 by 7. So probability they don't sit next to each other. They don't sit next to each other. That is going to be equal to how much? 1 minus 2 by 7, and which is equal to 5 by 7. And this. So any doubts now, please respond. Can I move to the next slide? Okay, so sometimes it's easier to calculate the probability of our event not occurring than it is to calculate the probability of an event which is occurring. All right. Now let's move to the next part. So we have seen the addition principle. Now we'll talk about the probability and multiplication. Let's start with a basic example. Try this, all of you. Okay, now just see it. Two six-sided dice, one red and one green are rolled. What is the probability that the red dice goes to and the green dice goes to? Now, first of all, what is the number of successful outcomes? We need red showing 2 or the green showing 5. There is only one way. Yes or no? And the number of possible outcomes. Number of possible outcomes. That is 6 into 6, which is equal to 36. So the probability is simply equal to 1 by 36. Any doubts to anyone now? Please tell me. If I say what is the probability that we are getting a red, 2 of red, that is 1 by 6. And if I say what is the probability of getting a green of 5 on another dice, that is 1 by 6. यार यहाँ पे given है Jatin अभी ये मेरा probability of red. Now I need to find out the probability of red of 2 and probability of green of 5. So एक ही तरीका होगा ना, पहले पे red और दूसरे पे 5, और कोई possibilities हो सकता है Jatin? Tell me. I need one dice is showing 2 and the red dice is showing 2 and the green dice is showing 5. So red is showing 2, green is 5. There is only one way. There is no other ways. Clear now? So in this case, probability of red 2 and the green 5, it is nothing but probability of red is showing 2 into probability that we are getting the green 5. So probability of red 2, that is 1 by 6, and the green one is showing 5, that is 1 by 6, which is equal to 1 by 36. And this is known as a multiplication principle. So the meaning of the term and means nothing but that is multiplication. Is that part clear to all of you? Okay. And also remember, here the two events, it must be independent of each other. Means independent means what? The happening of the first event does not affect the happening of the other event. Now, getting 2 on red die and getting 5 on the green die, whether they are depending on each other? No, they are not depending on each other. So if they are not depending on each other, then the probability of A and B is always equal to probability of A into probability of B. Can I move to the next slide? Please tell me. Let me take one more example. Try this. There are two dice. One of them is red and the other one is green. What is the probability that the red dice show an odd number? So number of successful outcomes. So red is showing odd numbers. So R1, R3, and R5. Three possibilities. And the green one, it is showing an perfect square. So G1 and G4. There are two possibilities. So can you say 3 into 2, that is equal to 6? Because we are just picking two dice. So for the first dice, there are three possibilities. For the second dice, there are two possibilities. So I'll get a total number of successful outcome. It is going to be equal to 3 into 2, which is 6. Any doubts to anyone? And what is the number of possible outcomes? So the number of possible outcomes, I can say that is equal to 36, 6 into 6. So the probability is 6 by 36, which is equal to 1 by 6. Please tell me if there is any doubts to anyone. Now, I can also write this equation that probability of red dice is showing odd and green dice it is showing what? That is equal to the perfect square. PS means perfect square. So that is the probability that the red dice is showing odd into the probability that the green dice it is showing a perfect square. So red is showing an odd number. The probability is 3 by 6. There are 6 numbers out of which 3 of them are odd into green dice is showing a perfect square. So there are 6 green possibilities and there are 2 numbers which are perfect square. So that is equal to 1 by 6 and that is that. So I hope that now the basic funda of multiplication principle is clear to all of you. When to multiply. Okay. So I can generalize it and I can write down this. That if A and B are possible outcomes for 2 independent events, then probability of A and B it is equal to probability of A into probability of B, provided that the 2 events are independent. Independent means what? The happening of one event does not affect the happening of the other event. Clear now? Can I move to the next question? Try this. Okay, now the Indians play the Australians 4 times, and the Indians are much better team. Most of you are right. What is the probability that the India win all the 4 games? Okay, India win all the 4 games. So can you say probability that the India win all 4 is equal to probability that India win game 1. G1 means, or like, let me write down that the Indians win game 1 into probability that the Indian wins game 2. Yes or no? Into probability that the Indian wins the 3rd game also, and into probability that the Indian wins 4th game also. And all of them are independent events because the result of first match it is not going to affect the result of the second match. So all the matches are independent of each other. So we can multiply them. So it is simply 3 by 4 into 3 by 4 into 3 by 4 into 3 by 4, which is equal to 81 by 256. And that is that. Any doubts now? Please respond. Can I move to the next slide? Try this. Question number 24. Try this one. Okay. How many matches are played total? 7 matches. Yes or no? It says, what is the probability that the India will win the championship in exactly 7 games? So, what is the result of the first 6 match? Tell me. What is the result of first 6 match? How many matches will be won by India and how many of the matches will be won by Australia in the first 6 match? Yes, that's right. So it means India wins three, India wins three, and Australia wins three. Then only the result will be decided in the seventh match because it says that what is the probability that India will win the championship in exactly 7 games now. So if India is winning the 3 matches, so can we say there will be a possibility that the first match is won by India, second by India, third by India, and the next 3 by Australia? Or first by India, second by Australia, then next 2 matches by India, and the next 2 by Australia? Or like first 2 matches by India, or I say the first 2 matches by Australia, first 3 matches by Australia, then the next 3 by India, or so on? Yes or no? So what is happening in this case? The number of ways, number of ways in which 3 matches is won by India and the 3 matches is won by Australia. It is going to be equal to 6C3 into 3C3. That out of the first 6 matches, which 3 matches won by India and which 3 matches won by Australia? And that will be equal to 20 ways. Is that clear to all of you that there are 20 possibilities? Or I can say the order it can be like this one also. That is, there are 6 now, so that is factorial 6 by factorial 3 into factorial 3. That will be also comes out to be 20. So this is a sequence in which the result of the first 6 matches here. Now, in each of these sequence, like when I say the first case here, the probability that the India win is nothing but can I say that is equal to 3 by 4. Like if I write down that is I, A. That is one of the order. Or India, Australia, India, India, Australia, Australia, or and so on. So India win, that is 3 by 4. India win 3 by 4. India win 3 by 4. Australia win 1 by 4, 1 by 4, or 1 by 4. Or means plus. Then India win 3 by 4. Australia win 1 by 4. India win 3 by 4. India win 3 by 4. And the Australia win 1 by 4 into 1 by 4. Or means plus and so on. So can you say the same solution, it will repeat how many times? How many times I'll get this sequence? 20 times. And in all these 20 cases, I'll get the same value. The 3 by 4 will repeat 3 times and 1 by 4 will repeat 3 times, isn't it? So the probability it is going to be equal to 20 into 3 by 4 raised to power 3 into 1 by 4 raised to power 3. And then into, now the 7th match will happen. And the 7th match, the India wins, the probability is nothing but that is going to be equal to 3 by 4. So this is the answer. Any doubt, please ask me right now. Now, the question is that the probability that India will win the grand championship in the 7 matches. Na? So 7 matches means 7th match is won by India in the first 6 matches. The 3 matches is won by India and 4 by Australia. Then only because the championship will be won by the team which won 4 games. So in the first 6 games, The 3 matches is won by India and the 3 matches is won by Australia. So the probability that India wins, it can be 3 by 4 into 3 by 4 into 3 by 4, and Australia 1 by 4 into 1 by 4 into 1 by 4. So that is the result of the first 6 matches. So 3 by 4 raised to power 3 into 1 by 4 raised to power 3 in 20 cases. And then after that, after once the 6 matches happen, then the next match is going to be won by India. Then only India win the championship. And what is the probability that India will win the 7th match? That is 3 by 4. So I multiplied by 3 by 4 here. Is that clear to all of you? Please respond now. So this I have written. Let me write it down also. One more step here. Just a minute. So this is 20 into this. This is for the first 6 match. And this is the 7th match. So I hope that now it is clear. Can I move to the next question? Try question number 25 now. What is the probability of India winning the championship in any number of games? Now, what is the minimum number of games India need to play to win the tournament? What is the minimum number of games India need to play? 4. So India can win the game either in the 4-match tournament or in the 5 matches, or I say probability that the India win the tournament in 4 games, or Indian win the tournament in 5 games, or India win the tournament in 6 games, or Indians win the tournament in 7 games. Maximum 7 games, yes or no? Now, 4 games. So 4 games out of 4 games, the 4 games are won by India, all the 4. And in all the 4, the probability is 3 by 4. So can you say into 3 by 4 is to power 4? Yes or no? Plus probability that the India win 5 games. So in the 5 games, 4 games is won by India. Okay, or I'll say what is the result of first 4 matches? In the first 4 matches, 3 of the matches is won by India. Which 3? 4 C3. Is that clear? For result of the first 4 matches, then only 5th match is needed. Yes or no? So in the first 4 matches, 3 matches won by India and 1 by Australia. So 4 C3 into, I can write down 1 C1. And in all the 3 matches, the probability of winning India is 3 by 4. So 3 by 4 is to power 3. And in 1 match, Australia won, so into 1 by 4. And then in the 5th match, India will win. That is 3 by 4. Is that clear to all of you? Please respond. Plus 6 games. So in the 6 games, if India is winning the tournament in 6 games, so in the first 5, India won 3. So out of the first 5 matches, India won in the 3 matches. So 5C3, and Australia won 2. So that is 2C2 into. India wins 3, so that is 3 by 4 raised to power 3. Australia wins 2, so that is 1 by 4 whole square. And the last match is won by India, so into 3 by 4. And similarly for the 7th game. So first 6 match. So result of first 6 match, 3 games out of 6, 3 was won by India and the remaining 3 were won by Australia. For India, the probability is 3 by 4 raised to power 3. For Australia, the probability is 1 by 4 raised to power 3. And then the last match, 3 by 4. And this is the answer. Any doubts for anyone now? Please respond. And if you solve this, you will get the answer as 3807 by 409. And that. So can I move to the next question now? All right. So try this question. Question number 26. Let's say two person A and B throws a coin alternately till one of them gets a head and wins the game. Find their respective probabilities of winning if A starts first. So let's say I'll say probability that A wins the game. So can we say A can get a head in the first turn, or A will get a tail, B will also get a tail, and then A will get a head, or A get a tail, B get a tail, then A get a tail, and B also gets a tail, and then A get a head, or A gets tail, B gets tail, A tail, B tail, A tail, B tail, and then A is getting head, or so on. So what is the probability of getting a head? In the first case, that is 1 by 2, or means plus. Probability of getting tail, that is again 1 by 2 into 1 by 2, and head is again 1 by 2, or means plus. The probability of getting 10 in the first four classes, so that is 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 and into 1 by 2, or means plus and so on. So I'm getting this is equal to 1 by 2 plus 1 by 2 cube plus 1 upon 2 raised to power 5 and so on. So this is a series of what? GP. Okay, GP. And the sum of infinite terms of GP, it is always equal to what? A upon 1 minus R. First term upon 1 minus common ratio. The first term is 1 by 2 upon 1 minus. Common ratio is 1 by 2 square. So it will be equal to 2 by 3. And that is answer. So any doubts to anyone now? So probability that A wins is 2 by 3. So what is the probability that B will win? That is 1 minus 2 by 3, which is equal to 1 by 3. And that is. Any doubts to anyone now? Please respond. Okay. So try to solve next question. Let's say, yes, that's right, Oscar. Probability. Now, these are the standard NCRT questions. Probability that A will win the game if he gets 6, or A is not getting 6, B is also not getting 6, and then A is getting 6, or A not getting 6, B not getting 6, then A turn A is not get 6, B will not get 6, and then A will get a 6, or so on. So the probability of getting 6 is 1 by 6 plus not getting 6, that is 5 by 6 into 5 by 6 into 1 by 6. Or I can say 5 by 6 into 5 by 6, not getting 6 is 5 by 6 into 1 by 6 plus 4. So here the first term is 1 by 6 upon common ratio is 5 by 6 whole square. So if you solve this, you'll get the answer as 6 by 11. That's right. So probability that A wins is 6 by 11. So probability that B wins, it is going to be equal to 5 by 11. And that. So any doubts to anyone in these two questions, 26 and 27, please respond. No? All right. So let's move to the next question then. Try this. Okay. Now just see it here, all of you. In a tennis game, if the players are tied at deuce, then the game continues until one player has won two more points. Okay, so the game will continue after this until one player gets two more points than the other player. If Mahesh and Sanya are playing tennis, okay, and reaches to deuce, and the Mahesh has a 3 by 5 probability of winning any given point, then what is the probability that Mahesh wins the game? Okay, so let us assume that the probability that Mahesh wins the game. Mahesh wins the game, it is equal to P. So what can happen? Once you reach to deuce, both the points are won by the Mahesh. Or first point is won by Mahesh and the second point is by Sanya, and again you reach to the deuce. Yes or no? And once you reach to the deuce, after that again, what is the chance of winning the Mahesh? Or the first point is won by the Sanya and the second by Mahesh, and then again you reach to the deuce as both of us got an equal number of points. Okay. And then after that, Mahesh is winning. And probability that the Mahesh wins is 3 by 5. So in the first case, the probability is 3 by 5 into 3 by 5. Or first match is won by Mahesh 3 by 5. And second is won by Sanya, that is 2 by 5. And the deuce happened. And after the deuce, the Mahesh will win, that is P. The game will continue. Okay, you can keep continuing the game. Then first is won by Sanya, that is 2 by 5. First is won by the Mahesh 3 by 5. And again the deuce has happened. And after that, winning the probability it is equal to P. So the P is equal to 3 by 5 into 3 by 5 plus 3 by 5 into 2 by 5 into P plus 2 by 5 into 3 by 5 into P. And if you solve this, you'll get the value of P, which is 9 by 30. Perfect, Avinash. So this is the answer. Any doubts to anyone now? Mohit, Bhaskar, Jatin, Aditi, Isit, Madhur. So can we move to the next slide now? Last. Which part last? I just need to solve this equation. We know that the probability, there will be three different possibilities here. Both the matches are won by Mahesh, so Mahesh will win the tournament, or Mahesh wins, then Sanya wins, and again will reach to the deuce as both of them has got 1-1 win. And once the deuce has happened, then after that the probability that Mahesh will again I need to follow the same thing, so into P, and so on. First is won by Sanya, then Mahesh, and then the deuce has happened, and then again winning the match after the deuce, that is P. And the sum of these three must be equal to the P. Clear now? All right. Try this one. Seven shots are fired at the target. Then a shot will hit the target. What is the probability that it will hit the target exactly twice? So out of these seven, there are two hits. Which are the two hits? Can you say 7C2? And the remaining 5 is missed. So that is 5C5. And in all these seven, the probability of hitting the target is 1 by 3. So 1 by 3 raised to power 2. And in the remaining 5, it has missed the target. So that is equal to 2 by 3 raised to power 5. And this is the answer. Any doubts to anyone now? Please respond. There will be 7 cases. So out of the 7, 2 of the hit and 5 of them are misses. Okay, that's right. Can I move to the next question? And what is this particular Result is known as, there is a special name given to such type of the result. Do you know that? I think Bernoulli's distribution, isn't it? Bernoulli's theorem. But yes, the theorem are not important. This particular theorem is known as Bernoulli's theorem. Can I move to the next question? If this is clear to all of you, try this. नहीं. It says the probability of a shooter hitting a target is 3 by 4. How many minimum number of times must he or she fire so that the probability of hitting the target at least once is more than 0.9? So probability that it will hit the target at least once, it is nothing but greater than 0.99. So at least one, it is always equal to 1 minus the probability of none. At least one is always equal to total minus none, and total is 1. So 1 minus that probability that none of them will hit the target, it is 0.99. So which means what? That the probability that none of them will hit the target, it is going to be less than 1 minus 0.99. What is 1 minus 0.99? That is 0.01. And probability that none of them are hitting the target, that is 1 by 4 raised to power n. Because hitting a target is 3 by 4. So if it is not hitting a target n times, so 1 by 4 raised to power n. And this value, it is less than 1 by 100. So this implies that 4 raised to power n, it is greater than 100. So can you guys tell me what is the minimum value of n? It has to be greater than equal to 4. 4 square is, okay, 4 cube is 64. And 4 raised to power 4, 4 raised to power 4, it will be equal to more than 100. So the minimum possible value of n, it is nothing but that is 4. So the answer is 4. Is that clear to all of you? All right. All right, so we'll stop here. Okay, and tomorrow we'll discuss few more concepts. One of the important concept of probability tomorrow. Okay, that is known as the Bayes theorem. Very important for XAT and IST. We'll discuss that Bayes theorem tomorrow. So any doubts to anyone in the today's session, please discuss with me. NVAT weight is that you need to check, maybe 1 or 2 questions. All right. So good night to all of you. See you all tomorrow. Good evening, everyone. Can you all hear me? Siddhant, Anupam, Avinash, Bhaskar, Bhumika, Damini, Teis, Isit, and all of you? Yes. All right. Okay. So let's start the today's session, the second season of probability. All right. Now, so here, first of all, today we'll start with the probability with the dependent. We have seen the independent events and the mutually exclusive events in the yesterday session. So today we'll see probability with the dependent event. Okay, let's start with an example here. 2 cards are dealt here. All right. From a standard pack of 52 cards, what is the probability that the first card dealt is a diamond, and the second card dealt is a spade. Please tell me. Anyone? Okay. Now, there are total of 52 cards, and the first card is diamond. How many diamonds are available? Please tell me how many diamonds are available. Out of 52, how many of them are diamond? 13. So, can you say that the first is diamond? The probability of this is nothing but that is equal to 13 upon 52. Is that clear? 13 upon 52 into. And the second card. So, for the second card, can you say we have got how many choices? 52 choices or 51 choices? Only 51 from the remaining 51. It is depending upon the previous one into. Okay. Now, if it is 51, out of this 51, how many of them are from this club? That is 13. So, I can say that is 13. So, this is the answer which is equal to 13 upon 204. And this is the answer. Any doubts to anyone now? Please respond. No. All right. Tell me the answer of this question. A bag has 4 red and 6 blue marbles. A marble is selected and not replaced. Then a second is selected. What is the probability that both are of the same color? Anyone who can tell me the answer? Okay, let's see. The first thing that the probability that both of them are red in color. Okay, both of them are in red color. So that is the nothing but the probability that the first one is red into probability that the second one is red after first red is drawn, because it is dependent. So initially there are 10 marbles. Out of 10, there are 4 of them are red. So can I say that is 4 by 10 into. So now since one of the marble has been picked, so remaining marbles is 9. And from these 9 marbles, how many of them are red? That is 3. So 4 by 10 into 3 by 9. And 4 by 10 into 3 by 9, that is equal to 2 by 5. Or it might be possibility that the both of them are blue. Probability that both of them are blue. So first one is blue. There are 6 blue marbles out of 10. Once I pick one of the blue marbles, so remaining number of total marble is 9. And out of these 9, 5 of them are only blue. So into 5 by 9. So 6 by 10 into 5 by 9, that is equal to 1 by 3. The question says that the probability that both are same color. Okay. It says that the both of them are of the same color. So both same color. So it means it can be the probability, okay, that either both are red, okay, or probability that both are. So probability that both of them are red is 2 by 15, and probability that both of them are blue is equal to 1 by 3. So if I solve this, I think the answer will be equal to 7 by 15. Any doubts to anyone now? Yes, I have changed that. This is 2 by 15. So can I move to the next slide? Okay, try this. A bag contains 5 green, 4 red, and 6 white balls. 3 balls are drawn. Find the probability that all of them are of different color. Okay. Okay, let's see. First of all, now I'm picking three balls and the balls are drawn simultaneously. Okay. So the balls are drawn simultaneously. So the total number of ball is 15. And out of these 15, we are picking three balls. And all the three balls simultaneously. So I can simply say 15 C3. Okay. Now, all of them are of different colors. So one of them is green. So out of five, I need to pick one of them green. Out of four reds, I need to pick one of them. That is nothing but that is one red and then one blue. So that is 61. So if you solve this, what is the value it is coming out to be? Anyone? 5 4s are 20 and 5 into 4 into 6. So 5 into 4, 20 into 6, 120. All right. Upon 15 into 14 into 13 and divided by factorial 3. So that will be equal to 6. So this will be the answer. If you solve this, what is this value comes out to be here? 15 into 8. What is this expression is equal to? Please tell me, all of you. Or I can say it is simply equal to 5 into, okay. Or I'll just keep it as it is here. Okay, that is equal to, that is 5 into 4 into 6. And then 15 into 14 into 13 and then into 6. This is what I'll get. Isn't it? I'm not solving this. I'm just flipping this in this form. Any doubts to anyone? Please tell me now. Part B. Now it says balls are drawn one after another without replacement. So what are the different possibilities? It is a without replacement. So first one, it can be green or the red followed by white, or it is green, white, red, or I can say it is nothing but white, red, green, or it can be nothing but white, green, red, or I can say that is equal to red, green, white, or red, white, green. So these are the total of 6 possibilities. So now tell me one thing, if the first one is green, so the probability of getting green out of 15 balls, that is equal to 5 by 50. So once I take one of the green, so next one is nothing but that is red, and it is without replacement. So now we have got 14. Yes or no? So we have got 14 balls, and from these 14, how many of them are red? 4 of them are red. So 5, 4 by 14. Okay, into then it is nothing but it is coming out to be how much? How much? That's right. That is white, nothing but that will be 6 by 30 or means plus. Then first one is green, again 5 by 15. Once I pick one of the ball, we are left out with remaining 14 balls. And from the remaining 14, how many of them are white? That is 6. And from the remaining 30, now how many of them are red? That is 4. So 5 by 15 into 6 by 14 into 4 by 30. Then again, first one is white. That is 6 by 15. Once I pick white ball, now the remaining number of ball is 14. So out of this 14, one of them is red. That is 4. And then into 5 by 30. Now, if you observe here, the numerator and denominator, all of them are same, isn't it? 15, 14, 13, 15, 14, 13, 15, 14, 13. And the denominator or numerator also, 5, 4 into 4 into 6, 5 into 6. Only the order is different. So can you say, in each of these 6 cases, we get the same value? Yes or no? So its final value, it is going to be equal to how much? This expression is equal to nothing but that is 5 into 4 into 6 upon 15 into 14 into 13 into 6. Is that clear to all of you? Any doubts to anyone? No. All right. So this is the answer. And if you observe here, in this case, what the answers are saying, whether I am picking all the balls simultaneously or even one by one without replacement, the answers are basically same. The only difference here is that here we are doing the arrangement, whereas in this case we are directly doing the selection. Yes, I have already discussed all. It will be same. Now, but it is the with replacement. But do not try to mug up these things. Just if it is given the replacement without replacement, so follow the standard method. Now see. Now with replacement. So with replacement, can you say every time it will be 15 balls? Yes or no? Every time it is going to be 15 balls? So like it is 5 by 15. Okay. 5 by 15 into. Again, since the ball has been replaced, again the total number of balls is 15. So red 4 by 15 and then again 6 by 15 because it is a case of replacement. So second time, first one is green, that is 5 by 15. Second one is nothing but white, that is 6 by 15. And the third one is equal to red, so I can say 4 by 15, and so on. So this will be equal to nothing but that is 5 into 6 into 4 upon 15 into 15 into 15. And how many times? I'll get this as also 6 times. So this is the answer. Yes, Avinash, 15C3B, what do you mean by 15C3? So any doubts to anyone in these three questions, please tell me. So can I move to the next slide? Total minus B part answer. You are saying total. Nee, so what is the total minus in the probability? How do we do minus? Total minus B part answer, which I didn't understand. टोटल कैसे कह सकते हैं? टोटल तो 15C3 हो गया ना. It says balls are drawn one after another without replacement. So what are you trying to say? Total minus it. One minus. Now you can say one minus. You can probably say that it is equal to one minus when none of them. Okay, if at least two of them are of the same color, in that case you can say. But that is going to be the length. So you are saying one minus without replacement is equal to with replacement? No, that is a wrong approach. Completely wrong. You can't say that. That one minus without replacement is equal to with replacement. No. Probability of happening of one event plus probability of happening of another event. जहाँ पे तो दो अलग अलग चीजें ना, so that is a wrong thought process in fact. You can't say that one minus without replacement is equal to with replacement. No. Because with replacement, without, it is considered as totally different cases. Clear now? Can I move to the next slide? Okay. Try question number 4, all of you. I hope that you all have gone through the new notification of the NMAT paper, which was released yesterday. Have you all gone through the NMAT? Yes. A lot of changes has been done. Now this is a computer adaptive test. Computer adaptive test. Do you know what is a computer adaptive test? Yes, totally on GMAT patterns. For example, if you solve a difficult question, then the next question is going to be more difficult. If you solve that difficult question again, then after that the next question is going to be difficult. But if you're not able to solve the difficult question, then you get a easier question. So it is more on the GMAT pattern. Number of questions and everything is same, but the scoring pattern will change. It will be more on the lines of GMAT pattern. Okay, guys. So what is the answer for this? Yes, we can discuss that later on. A bag contains 4 red and 6 white balls. So there are 4 red and 6 white balls. Another bag has 7 red and 5 white balls. One ball is selected, but that ball is selected from which bag? Either from the first bag or the second bag, no idea. So can you say if one ball is selected, so the question arises from which ball we are selecting the bag? So what is the probability of selecting the first bag? What is the probability of selecting the first bag as there are 2 bags? So I'll say half. So probability that the first bag is selected is half. And from that particular bag, it is of red color. That is nothing but that is 4 by 10. Okay, plus. Then if I'm selecting the second bag, so probability of selection of second bag is again half. And from that particular bag of getting a red color, that is going to be 7 by 12. Any doubts now? So let's move to the next slide. So a bag contains 4 red and 6 white balls. Another bag has 7 red and 5 white. Okay. So one bag has got 4 red and 6 white. Another bag has got 7 red and 5 white. Okay, 5 white. One ball is drawn from each. So from each of the bag we are drawing one. Find the probability that both are of them the same color. Okay. So the probability that the ball drawn from the first one is of red color. So that is 4 by 10. And from the second bag also we are picking the red color. So into 7 by 12. If both of them are red. Or means plus, both of them are white. So probability of getting white from the first, that is 6 by 10, and from the second white, that is equal to 5 by 12. So this is the answer. Any doubt now? This was an easy one. So can I move to the next slide? Try this. Select जतिन in the question नहीं पढ़ते हो ठीक से ना क्वेश्चन अच्छे से पढ़ा करो क्या गिवन है क्वेश्चन में one ball is drawn from each bag one ball is drawn from each bag so I do not need to select the bag हर बैग से एक एक लेना ही है that is already given try this all right. Box 1 contains 4 red and 6 white balls so there are 4 red and 6 white balls okay box 2 has got 7 red and 5 white so 7 red and 5 white one ball is transferred from first bag to second bag so one ball is transferred from first to second and then one ball is drawn find the probability that the ball drawn from the second box is of red color so the ball which we are transferring from box 1 to box 2 can you say there will be two possibilities either I can transfer the red colored ball or I can transfer the white colored ball. Yes or no? Now, if I am transferring red colored ball, what is the probability that red colored ball is transferred from first to second? What is the probability that the red colored ball is transferred from first to second? Tell me. 4 by 10. Out of 10, 4 by 10. So, if I am transferring the red, then in the box number 2, there are 8 red and 5 white. So, 8 red and 5 white. So, what is the probability of getting red? That is going to be 8 by 30. Or means plus if I am transferring the white colored ball. If I am transferring the white colored ball. So white colored ball transferring that is equal to nothing but that is 6 white. So that is equal to 6 upon 10. And if I transferred white, the total number of white balls here, it is going to be equal to 6. So there are 6 white balls among 13. So sorry, white will be, I need to pick red. I need to pick red from the box. So 7 by 30. So 7 by 30. And this is the answer. Any doubts to anyone? I need to push from the second, I need to pick red only, remember. So any doubts to anyone now? So can I move to the next slide? Then will get reduced to 9. Yes, of course, but that is in box 1. But the final ball we are picking from the second. So how is that important? वो तो box 1 में रहेगा 9 ही. Alright, now try this. Bag 1 contains 4 red and 6 white. There is 4 red and 6 white. Bag 2 and bag 3 and bag 4 is empty. Six balls are transferred from bag 1 to bag 2. So bag 1 to bag 2, 6. 4 balls is transferred from bag 2 to bag 3, 4. And bag 3 to bag 4, 2 balls. And now 1 ball is drawn from the fourth bag. Okay. So first I transferred 6 balls, then 4 balls, then 2 balls, and then I'm picking 1. And that ball is of red color. Now tell me that since all the intermediate bags are empty, so does it going to affect our probability? Please tell me. Can you say this is as good as picking directly 1 ball from the original bag? Yes or no? If it was not empty, then it would have mattered. How? If it was not an empty, then it would have been matter. Like in this case, the probability will be changing, isn't it? That I transferred from this to this. यहाँ पे matter कर रहा है ना because क्योंकि I have transferred some ball from here to here and then I'm taking 1, so it matters here. So that's why you multiply. But in this question, there is no transfer at all. All the bags are initially empty. So if initially all the bags are empty, पहले ही सारे bags empty है ना. So even if I put someone here, so whatever it is there, it is immaterial at all. It doesn't matter at all. For example, I'll say in a bag, I'm just saying that. Just imagine there are 10 balls in a bag. Close your eyes and close your eyes. All of you, please close your eyes and pick out of 10 balls are there in a bag. Let's say, or on your bed, there are 10 bags in a bag. Now you pick how much? 6. Okay, एक हाथ में सारे के सारे 6 balls ले लो. Now from those 6, now pick 4 in the second hand. ठीक है, second hand में अब तुम्हारे पास 4 है, बाकी सारे फेंक दो. Now from those 4, now pick 2. Okay, अब अपना दूसरा हाथ खाली कर दो, अब उन 2 में से एक ले लो. So can you say this is as good as picking 1 ball directly from a 10 balls? Yes or no? So the answer is straight away how much? That is 4 by 10, and this is the answer. Is that clear to all of you? The answer is simply 4 by 10. Any doubts to anyone now? Last night, every bag is empty. Every bag is empty. Okay, except 1 bag. So, any doubts now to anyone? So, can we move to the next question? Try this. Bag A has 3 white marbles. Okay, there are 3 white and 4 black. Bag B has 6 yellow and 4 blue. Bag C has 2 yellow and 5 blue. A marble is drawn at random from bag A. So this is bag A, then bag B, and then bag C. A marble is drawn at random from bag A. If it is white, a marble is drawn from bag B. Otherwise, if it is a black, a marble is drawn from at random from bag. What is the probability that the second marble drawn is yellow? Now, from the bag A, if I am picking the white, Okay, what is the probability that I pick the white colored from the bag A? That is 3 by 7. So if it is white, a marble is drawn from bag B. So I need to pick them from bag B. And what is the probability that it is of yellow color from bag B? That is 6 by 10. Okay. Or plus, if I pick up black from the bag A, that is 4 by 7. And if I pick up black from the bag A, then I need to pick from the bag C. And from bag C, what is the probability of getting yellow color? That is 2 by 7. So this is the answer. So any doubts to anyone now? Please respond. So can we move to the next slide? Okay. Now just tell me one thing. Becky lives 36% now. Becky lives in a place with a very clear sky. On Friday night, there is a 60% chance that she will see a shooting star in any given hour. In any given hour. Okay. There is a 60% chance. If Becky goes outside and watches the sky for 2 hours, what is the probability that she will see a shooting star? So 2 hours. So how many slot of 1 hour is there in 2 hours? How many slots are there? Two slots. So what can be the possibilities? There can be two cases. Probability that she is seeing the star in the first hour and not in the second hour. Okay, or probability that she sees the star in the first hour but not in the second hour, or she sees the star in the first hour as well as in the second hour also. So if she sees the star in the first hour, the probability is 3 by 5, and she is not able to see the star in the second hour, that is 2 by 5, or plus. Okay, here it is 2 bars, not in the second case, it is only 2. Probability that she is not able to see in the first hour, that is 2 by 5, but she is able to see the star in the second hour, 3 by 5. Or she is able to see in the first hour, 3 by 5, as well as in the second hour also she is able to see. So that will be equal to 21 by 25, which is equal to 84%. That's right. Any doubts to anyone? Please respond. 1 bar means she is not able to see the star in the first hour or the first slot, but she is able to see in the second slot. Okay. Now, other ways to solve this is also, I can say probability that she sees a shooting star. जतिन बिल्कुल सही क्वेश्चन, बट क्वेश्चन में पूछा क्या है? What do I need to find out? Do I need to find out the probability of that she is not able to see the star, or probability that she can see the star? What is the question? So sees the star, so how can I take the case if she is not able to see the star? Do I need to consider that case? Nahi na? Now, other ways I can say probability that she sees a shooting star is 1 minus probability that she doesn't see the star at all. Doesn't see shooting star at all. So that is equal to 1 minus 2 by 5 into 2 by 5. That will be also equal to 21 by 25, which is equal to 84%. So any doubts to anyone now? Can I move to the next question? Try this. Question number 10. %, no. Now, it says on Saturday night, Becky again goes for stargazing. This time the conditions are better, and there is a 80% chance that she will see a star in any given hour. We assume that the probability of seeing a shooting star is uniform for the entire hour. What is the probability that Becky will see a shooting star in the first 15 minutes? So I'll consider that probability. Probability of seeing a shooting star, in any given 15 minutes. In any given 15 minutes, it is equal to P. Okay. And then probability of not seeing a shooting star in any given 15 minutes, it is equal to 1 minus P. In the first 15 minutes or in any 15 minutes, she is able to see, it is equal to P, and not able to see, that is 1 minus P. So I can say probability no shooting star in 1 hour. Probability that she is not able to see at all any shooting star in 1 hour. Means what? Probability of no stars in first 15 minutes into probability of no stars in the second 15 minutes in any of the slot. Probability of no stars even in the third 15 minutes slot, third slot also, and into probability that she is not able to see any star even in the fourth slot also. So what is this value comes out to be? No shooting star in 1 hour. Probability that she can see a shooting star in entire 1 hour, it is 80%. So she is not able to see a shooting star in 1 hour, that is 1 by 5. So I can write down 1 by 5. It is equal to 1 minus e raised to power 4. So this implies 1 minus p, it is equal to nothing but 1 upon 4th root of 50. 4th root of 15. So this implies p is equal to, or I can write down directly that the value of p, to solve this equation, what will I get the value of p? It is equal to 1 minus 1 upon 4th root of 50. And this. Any doubts to anyone? When did I say it is 80% in the first 15 minutes? नहीं कह सकते ना, वो तो मुझे calculate करना है. So throughout the uniform means in any given hour, whether it's the first hour or the second hour or third hour or fourth hour, in any given hour. Okay. It doesn't mean कि पूरे यूनिफॉर्म आवर में एक घंटे में 80% चांसेस है. इट इज अ यूनिफॉर्म ईयर. सॉरी, फोर्थ रूट ऑफ 50, नो, फोर्थ रूट ऑफ 5 होगा. दैट्स राइट. सो 1 माइनस 1 अपॉन फोर्थ रूट ऑफ 5. So any doubts to anyone now? Can I move to the next question? All right. So now next section which we will talk about that is think about it. Okay. Just see here. Now here we are going to discuss probability problem that calls for a slightly different approach than the ones we have looked at so far. These are think about it problems. In these problems, we don't immediately dive into counting techniques or applying the principle of probability that we have learned so far. Instead, we think it of as a different way to view the problem and to reach the answers quickly. Often we can exploit symmetry. Okay, how to exploit the symmetry funda in probability that we'll tackle here. Okay, symmetry. Make a useful simplifications or make a leap of logic which allows us to fairly quickly solve the problem without getting bogged down in complicated or time consuming counting techniques. Also, doing this may give us better insight as to why our answer is correct. Okay, so can I move to the questions now? Try this. Very simple question. Now, two fair six-sided dice are rolled. So, two fair six-sided dice are rolled. If I follow the counting process, I can say two fair six-sided dice are rolled. What is the probability that the numbers shown on the two dice are same? Okay, numbers shown on the two dice is same. So we know that is equal to 1 1 or maybe 2 2 or maybe 3 3 or 4 4 or 5 5 or 6 6. These are the possibilities. So the probability it is nothing but 6 upon 6 into 6, which is equal to 1 by 6. Is that clear to all of you? Okay. Now the other thought process, like I told, because of the symmetry funda we can use here. There are two dice, dice 1 and dice 2. If I pick any number from dice 1, what is the probability of picking that number from the dice 1? Can you say it is 1 by 6? Let's say if I pick 3. So on the second dice also we need the same number, yes or no? On the second dice we also need the same answer. It will be automatically because it says both the dice are showing the same number. So the answer is simply equal to 1 by 6. That's it. Is that clear to all of you? So if I'm picking the dice, if probability of picking any one number from the first dice is 1 by 6. Whether I pick 1 or 2 or 3 or 4 or 5 or 6, that is 1 by 6. And once I get that number, so automatically the same number will be coming out on the next one. So answer is 1 by 6 only. Yes, you can say 1 by 6 into 1. It doesn't like that, okay, that I need to pick something else from the dice 2. We have got no choices for dice 2. So is that clear to all of you? Can I move to the next slide? Try this. The grunters and streamers are playing for the grand championship. Okay, forget about this previous chapter and this. That the grand championship is the best of 7 series, with the first team to win 4 games, winning the championship. Now, however, the streamers have improved so that each has the probability half of winning any individual games. If the grand championship series lasts exactly 6 games, what is the probability that the grunters will win? Now tell me. Can I say both of them has got equal chances, whether it's renters or streamer, both of them has got an equal probability, half and half? Yes or no? So what will be the final probability? The final probability will be also going to be equal to half on the answer. This is the answer. I do not need to make the 6 cases. If you remember, we have done make the cases in the yesterday's lecture, isn't it? India versus Australia, 6 matches, what is the result? But the probability of winning for both of them are same. So overall also it is going to be the same here. That is simply half. Any doubts to anyone? Or do I need to make the cases? जरूरत तो नहीं है ना? Jatin, the probability of winning the grunters and the streamer दोनों का equal chances है. So the series will last for 6 games. So even after 6 games, what is the chances of winning? For any team, it is going to be half because for winning each and every game is the probability is 50%. So overall also it is going to be 50%. Pure logical. Any doubts to anyone? So I can say you can sometimes take advantage of symmetry to more easily solve a problem. Otherwise, we can make the cases the way we have done in the yesterday's lecture. Now try this, all of you. Now just here. Point A, B, C are arranged clockwise in that order here. If the die shows a 1 or 2, we will be again at point A only. If the die shows 3 or 4, moves one step clockwise. For example, A to B. Alright. If the die shows 5 or 6, then I need to move counterclockwise from one step to C. So can we say probability of a stay put? It is what? 1 by 3. There are three possibilities, that is 1 by 3 here. And probability that I'll reach to point B, that is 1 by 3. And probability of reaching to point C, that is nothing but again 1 by 3. Any doubts to anyone? Probability of at point A 1 by 3, at B also 1 by 3, because there are two cases equally here. So 1 by 3. So the question is, what is the probability that after 8 moves the marker is again at point A? The answer is simply equal to 1 by 3. Clear now? Because there is a symmetry here overall. So can I move to the next question? Try this 14. Okay. Nikita is saying 1 by 3. It says there are 11 students in McGinn chemistry classes, including the Baker triplet, Nika, Billy, and Catherine. The teacher calls her 11 students in random order, one at a time, to her desk to tell each student his or her final grade. What is the probability that Billy is the first of the triplet that she calls to her desk? Okay. What is the probability that Billy is the first of the triplets that she calls to her desk? Now, what are the total number of possible arrangements? So, number of possible arrangements or order, that is 11 factorial, isn't it? And then we can make the cases in how many of the cases Billy is the first of the triplets. But instead of doing all this three, do the counting process. There are three triplets. So can you say each of the three triplets has got equal chances? Yes or no? That among those three triplets, any all the three triplets has got an equal chances. So the probability will be straightforward 1 by 3. And that is the answer. Not needed to do all the counting and yeah. No, it doesn't matter at all. The question is that there are 11 students, but what is the probability that Billy is the first of the triplets? Among the triplets, there are three triplets. And out of these three triplets, A, B, C, what is the probability that B will be the first one to call? So among the, so Billy ho, chahe A ho, ya C ho, each one of them has got equal chances of calling for these three triplets. So the answer is simply 1 by 3. Is that clear to all of you? We can also do by the counting techniques, but that is not needed. Try this. Question number 50. Let's see. It says there are 11 students from question number 14. Make up Mr. Palmer's history class again. So there are 11 students, and including the triplets A, B, and C. And in addition to A, B, C, there are 8 more people. As before, the teacher calls all 11 students in random order, one at a time, to his desk to tell each student his or her final grade. However, the first time he calls a student to his desk, Billy is in the bathroom. Okay, and therefore can't be called up. But he's back in time for the rest of the students to be called. What is the probability that Billy is the first of the triplets to be called on the test? So among the triplets, Billy is the first one to call. Also find out the probability that A is the first of the 3 called to the test. Okay. Now tell me, what is the answer for this one? Now tell me one thing. Probability that Billy was called. Now, first of all, Billy was the first one to call. So tell me one thing. There are Billy is not available right now in the beginning when the first call was made. So when the first call was made, how many persons are there? Tell me. How many persons are there when the first call was made? 10 persons. But out of these 10 persons, okay, only there are 8 people who is not a part of the triplet. A and C is a part of triplet. So when the first call was made, the probability that there was no triplet in the first call, that is equal to 8 by 10. Yes or no? Is that clear to all of you? When the first call was made, because the question is asked that what is the probability that Billy is the first of the triplets. So Billy can be the first of the triplets who has been called. That is only possible if during the first call none of the triplet was called. So during the first call none of the triplet was called. The probability is 8 by 10. And now Billy is back. So now can you see A, B, and C? All of them has got equal chances of calling the yes or no? So into 1 by 3. So 8 by 10 into 1 by 3, which is equal to 4 by 50. And this is the answer. Any doubts to anyone now? Why not 0? Why not 0 in the first case? 0 कैसे होगा? कोई और तो कॉल करेंगे ना. There are a lot of possibilities here. What is the question asked? Tell me, Nikita Mohit. क्या पूछा है question, Nikita? Question is, what is the probability that the Billy was what is the probability that Billy is the first of the triplet to be called to the desk? When the first call was made, Billy is not available, but other persons are there. In the other person, it might be possible that A is called or C is called. And once the Billy will arrive, then if A has been called, so can the Billy be the first person? No. So everything depends in the first call. The Billy can be the first person among the triplet. That is only possibilities if in the first call none of the triplets has been called. Is that clear? कि जब भी उसने पहली बार टीचर ने नाम लिया उसमें से उसने किसी ट्रिपलेट का नाम नहीं लिया, तभी तो बिली आ सकता है ना बाकी 3 में से पहले. That's why it is 8 by 10. And once now there are all the persons are in a line, so among these three, probability of calling any one of them is 1 by 3. So that's why 8 by 10 into 1 by 3. Is that clear to all of you? Please respond now. Now the second question is also find out the probability that Anika is the first of the three called to the test. Now tell me, probability that B is not the first among three siblings. What is that probability? Can I say that is equal to 1 minus 4 by 15, which is equal to 11 by 15? And can I say if B is not the first among the three siblings, so probability that A is the first person to be called, it is going to be equal to the probability that the C is the first person to call. Yes or no? दोनों के लिए तो equal chances होंगे. Probability because B is not there. Probability that A is the first person to be called is equal to probability that C is the first person to call. So that is equal to half into 11 by 50. Okay, so that is coming out to be equal to how much? 11 by 30. So what I am getting here, that the probability that A is called for the first, A is the first among the triplet, it is 11 by 30. B is the first among the triplet, that is 4 by 30. And C is the first among the triplet, that is 11 by 30. And if you add all of them, are you getting 1? Yes or no? Please check. Are you getting 1? Some has to be 1. Yes, RI, please tell me. No, 11 by 30 plus. Achha, this is 4 by 15 tha na? 4 by 15 means that is equal to 8 by 30. You have calculated 4 by 15. So that is 8 by 30. Now, is it coming out to be 1? Yes. So that's right. So we have used the funda of symmetry here instead of doing the counting. Any doubts to anyone now? Please respond. So can I move to the next question? Okay. The numbers 1 through 8. The numbers 1 through 8. 1, 2, 3, 4, 8, 5, 6, 7, 8. Which is a multiple of 5. So we are arranging 1 to 8 here. So what is the last digit? The last digit has to be 5. Yes or no? The last digit has to be 5. What is the probability that the number is greater than 60 million? So if the number is greater than 60 million, at the first place I can put either 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. But if it is greater than 60 million, so can we say the first place, it must be occupied by either 6 or 7 or 8? Yes or no? The first place must be occupied by either 6, 7 or 8. Okay. Remove here. The first digit has got how many choices? 7 choices. 1, 2, 3, 4, 6, 7, 8. Because for multiple of 5, the last digit must be 5. So what is the probability? 3 by 7. We do not need to form the numbers. The first place has got 7 choices. And only in these 3 cases, I can get a number which is more than 60 million. So the answer is simply 3 by 7. Any doubts for anyone now? You can do also the counting, find out the total number of digits, but that's a lengthy method. So can I move to the next slide? So try this. Now, the question says, what is the probability that a random rearrangement of the letters in the word mathematics will begin with the letters math? Okay. So I'll say there are total of 11 letters in which M is repeating twice. Okay, M is repeating twice. A has repeated also twice. T has repeated twice, and H has only one. Okay, because I need to form the letter math. Okay, so it says I need MATH. It should start with the math. So probability of selecting the math M, that is equal to 2 by 11, into probability of selecting A, that is equal to 2 by 10, and probability of selecting T, that is equal to 2 by 9 now, and then H is the next letter, that is the probability is 1 by 8. So the answer is 1 upon 990. And this. Any doubts to anyone now? The first letter is M, 2 by 11, second letter is A, 2 by 10, third is 2 by 9, and the last one is H, it is 1 by 8. So I hope that this method is clear to all of you. We can also do the counting, count how many letters are there, you'll get the same answer. All right. Now, let's move to the next part, an important part, that is geometric probability. Questions of probability involving the fundas of the geometry. Okay. Sometimes we are faced with the probability problems in which there is no available quantity for us to count. The counting might be difficult. One common example of this is in geometry. In geometric probability problems, instead of counting individual items or outcomes, we'll use as our counts various geometric quantities such as length or areas. And these problems have a very different flavor than the problems that we have seen until now. But the general technique is similar. Okay. Now, always the probability of the success in this case is size of the successful reason upon size of the possible reason. So since we are not doing any counting, so there can be area or there can be a length also. So we'll see in the questions. Can I move to the questions now? Please tell me. Now try this, all of you. Now just see. It says in the following figure, AC has length 5 and AB has length 4. A point P is selected randomly on segment AC. What is the probability that P is closer to B than to A? Okay, now just see it here, all of you. So this is A to C, all right, and then there is a point B. So this is point A, this is a point C, and then this is a point B. All right. So this is, let me write it down. This is A, this is B, and then this is C. This is 1, this is 4. And I'm selecting a one point. What is the probability that it is closer to B than closer to A? Now, what is the midpoint of A and B? I'll say this is the midpoint of A and B. Okay. If this is the midpoint of A and B, let's say mark it as this is point B. Okay, this is a point B. Okay, so in that case, the length of AD is equal to 2 and BD is equal to 2. So can I say if my point, if it is in this particular region, in the region DC, it will be always closer to B in comparison to closer to A? Tell me yes or no. If I select point C on this line, from D to C, it will be always closer to B in comparison to A, because in that case, the point, let's say that point, the distance between that point is always going to be less than 2. But from A, it is going to be more than 2. So, what is the answer now? I can write down step by step probability that P is closer to B, closer to B than to A. It is equal to length of successful reason. Now, in some of the question, you need to take length. So, length of successful reason upon length of possible reason. Length of possible reason. So, successful reason, it is equal to DC, and the possible reason, I can select the point anywhere from the A to C. So, the answer is equal to 3 by 5. Any doubts to anyone now? Can I move to the next question? Try this, question number 19. Okay, 1 by 3, 1 by 4. Okay. A real number x is selected randomly such that x is lying between 0 to 3. Okay. So, mod of x minus 1, it is less than equal to half. So, what does this imply? That x is nothing, x minus 1, it will lies in the range minus 1 by 2 to plus 1 by 2. Okay. So, add 1 throughout the equation, x is lying in the range half to 3 by 2. But can we count here? No, we cannot count. So, I'll say that the probability that mod of x minus 1, it is less than equal to half, is equal to length of the segment. Which segment is satisfying this criteria? Length of the segment where x is lying in the range 1 by 2 to 3 by 2 upon The point is selected at random from 0 to 3. So length of segment from 0 to 3. So denominator is 3, 0 to 3, the total length is 3. And from 1 by 2 to 3 by 2 on the line, what is the distance from 1 by 2 to 3 by 2? What is the distance from 1 by 2 to 3 by 2? That is half to 0.5 to 3.5. 0 to 3, you are counting. Nikita, I told you, you cannot count. Do I need to count integers? Does this question says, Naina? So this is 1 by 3 and that is the answer. So basically, if you look at here, there is a line segment from 0 to 3. Okay, there is a line segment from 0 to 3. I'd say 0, 1, and 2, and 3. So I can pick any point, a number, any of the number. So if you are saying 4, 4 means you are taking 4 points. But if there are 4 points, no, there are infinite points on this side. So I'll take the length of the segment, not the number of the points. Number of points are infinite. But my point will always, to satisfy this condition, my point will be always in which region? 1.5 to 1.5, isn't it? 0.5 to 1.5. So the successful reason is the length of that region is equal to 1. So the answer is 1 by 3. So any doubts to anyone? Do not count the points. Can I move to the next slide? So if you are trying to compute a probability in which the outcomes are continuous as opposed to discrete, then we use geometric probability. It's a continuous, it's not a discrete that we cannot count here. Try this. Okay, just see it here. A real number x is chosen. We'll see that. Yes, Rohan, you are right. 45 by 100. A real number x is chosen at random from 0 to 100. Okay, so 0 to 100. So I can say this is 0 to 100. So what is this length? The denominator. What is the denominator? Is it going to be 99 Damini or is it going to be the 100? Do I need to count the points or do I need to consider the length of the reason? The length of the reason is 100, no? Okay. What is the probability that greatest integer function of root x is given? Okay, so I'll just make few cases here. Just tell me. Root x, square root of x, and the greatest integer function of root x, and then interval. And what is the length of that interval? So now tell me, if x is equal to 0, matlab root x is equal to 0. Greatest integer function of root x is 0. So it means root x, it must be between 0 to 1. Yes or no? जो root x की वैल्यू होगी वो तो 0 to 1 के बीच में होगी, तभी the answer greatest integer function is coming out to be 0. So it means the value of x, can we say the value of x, it means it is lying in the range 0 to 1. Please tell me yes or no. Is that clear? Am I audible? Nikita, Damini, Avinash, Jatin, everyone, please respond. Integer है ना? So what is the smallest integer? That is 0. So if I say integral value of root x is 0, so if the integer value of root x is 0, so it means the value must be between 0 to 1. If the value is between 0 to 1, then only the integer value can be 0, no? Yes or no? So if I take a square, what is the root x is lying between 0 to 1. So if root x is lying between 0 to 1, okay, then only by its greatest integer function is going to be 0. So which means x is nothing but it is lying in the range 0 to 1. Is that clear now? Please tell me. That I need to pick the number only positive numbers in the range 0 to 100. Okay. My numbers are only in the range 0 to 100. So do I need to consider the negative number? Nahi na? Then, now what are the possible values of root of x, greatest integer function of root of x? Forget about this one. If I say the greatest integer value of k, okay, it is equal to 0. So in what range k will lie? K must lies in the range 0 to 1, then only its integral value is 0. Please tell me yes or no. यही होता है. So this is what I have written. And k is what here? Root of x. So root x, it is lying in the range 0 to 1. So if I take a square, then I get x is lying in the range 0 to 1. So that's why x is lying in the range 0 to 1. Is that clear to all of you now? Please tell me yes or no. Now, if I say the greatest integer value of some number is equal to 1, so what does it mean? Can I say it means k is lying in the range 1 to 2? So which means root of x, it is lying in the range 1 to 2. So which means x is lying in the range 1 to 4. Is that clear to all of you? X is lying in the range 1 to 4. Please tell me yes or no. So if integral values, but we need the, okay, we need that this is an even number. Okay, we need an even number. So after that 0, the next even number is nothing but that is 2. Yes or no? Please tell me. यही होगा. And after that the next even number is 4, and then 6, and so on, 8, or maybe 10, and so on. So we need to concentrate on this. So now tell me one thing. If I say the greatest integer function of any number is equal to 2, so what is the range in which it will be equal to 2? Please tell me all of you. What is the range in which it can be equal to 2? If I say the greatest integer function of k, it is equal to 2. So it means k must lies in the range what? 2 to 3. Then only its integral value will be 2. Okay. And what is k? Remember, k is nothing but here root x. So square root of x is between 2 to 3. So if the square root of x is between 2 to 3, so can you say x is nothing but it is in the range 4 to 9? Please tell me yes or no. Is that part clear? So which means x is nothing but it is lying in the range 4 to 9. And you'll get a pattern. Now, if integral value is 4, if the integral value is 4, then it is possible when the value lies between 4 and 5. Yes or no? For any number between 4 and 5, the integral value is 4. Like 4.1, answer is 4. 4.2, answer is 4. So between 4 to 5, that's the root of x is between 4 to 5. So x is between which range? Can I say that is between 16 to 25? Okay. So you are getting a pattern: 0 square, 1 square, 2 square, 3 square, 4 square, 5 square. So here for 6, I'll get the answer. That is nothing but that is from 49, 7 square to 64. Please tell me yes or no. Or between 6 to 7, if integer value is 6, so it means the value is between 6 to 7. So 6 square, 36 to 49. That's right. Not this one, 36 to 49. Perfect. So 36 to 49. Okay. Then it will be 36 to 49. And then after that, it is between which to which number? 8 square. That is 64 to 9 square, which is 81. And then I can say that is 81. 9 square is 81. And then in the last case, what is that value? That's it. 10, so I can't take it because it has to be less than 100. It has to be less than 100. So in this case, the length of the interval from 0 to 1. What is the length of the interval? That is 1. From 4 to 9, the length of the interval is 5. From 16 to 25, the length of that interval, and not the integral points, the length of that interval. So from 16 to 25, the length of the interval is 9. You are getting a pattern 1 plus 4, 5, 5 plus 4 is 9. 9 plus 5, it is equal to, sorry, 9 plus 4, 13, and 13 plus 4, 17. So these are the number of possible cases. Is that part clear to all of you? Please tell me yes or no. 100 is not possible, Rohan, because it says less than 100. X is less than 100. So I am neglecting that 10. Okay. So what is the probability? The answer for this question is length, the total length of the successful reason, which is 1 plus 5 plus 9 plus 13 plus 17. And the total length is 100. So the probability will be equal to 9 by 20. And so any doubts to anyone now, please respond. So can I move to the next question? Try this. अरे यार वो आएगा decimal, but here we are talking about integer. Square root of 5 is 2 point something. What is its integral value, Jatin? What is its integer value of 2 point something? 2, na? Which is an even number. What is the answer of this question? Please tell me. It says Siddharth is driving one car in a line of cars. Okay. With about 150 feet between two successive cars. So the distance between two successive cars is nothing but that is going to be equal to 150. So I'll mark like this. Okay. That the distance between two successive cars, it is 150. Okay. Each car is 13 feet long. So the length of each of the car is 13 feet. So this is the 13 feet. And this is equal to 150 feet. So from this point to this point, the total length is nothing but that is going to be equal to 163. Okay. The total length from one point to the end of the car, that is total length is 163. Now it says at the next overpass, there is a large icicle. The icicle is about to crash onto the highway. If the icicle lands on or within 30 feet of the front of a car, it will cause an accident. So the total length it is equal to 163, and successful region that is equal to how much? 30 plus 13. That's right. 30 plus 13, that is 43. Because it says if the icicle lands on or within 30 feet of the front of a car. So the car is 13 feet and within or 30 feet. So maximum 30 plus 13, 43. So if the icicle lands on any of these 43 centimeter unit, then it will always cause an accident. So that's why 43 upon 160. And answer will be 43 upon 160. Any doubts now to anyone? Please respond. Can I move to the next slide? Try this. Half. Okay, we'll check that. Okay, 1 by 2. 1 by 2. Okay, we'll check that. Just wait. All right. Let's see. It says 3 points on the circumference of a circle are chosen at random. So we are selecting 3 points at random on a circle. So let's say this is a circle. Okay. What is the probability that the points are all on the same semicircle? Same semicircle. Now I select let's say one of the points. Let's say that point is A. Okay, I selected this point as A. Okay, point A. So it's diametrically opposite points. Diametrically opposite, that is nothing but that is going to be A dash. Okay. The second point which I selected is let's say B. The first 2 points I can select anywhere. Let's say the second point which I selected is at which place? This place. This is point B. So it's diametrically opposite. Diametrically opposite means that is B dash. So I selected 2 points A and B, and its diametrically opposite point is A dash and B dash. Now the point is how to select the third point. That all these 3 points, I'm talking about A, B, and the third point. It must be within the semicircle. Within the semicircle. That is the question. Now tell me one thing. See that. Okay, the third point, if it is lying within the semicircle, so that is only possible if I select the third point in this arc A dash B dash. Now just see how. If I select the third point within this circle, what is going to happen in this case? Let's see it here. Okay. Let me say this is my third point. Okay. So A, B, and C dash. Whether they will be in a semicircle, tell me now. Whether these 3 points are a part of a semicircle, please tell me now. Yes or no? Nahin na? So if I select any points in this region, can they be a part of a semicircle, these 3 points? Nahin. Okay. These will never be a part of a semicircle. That's right. Now, so tell me one thing, step by step, all of you. Probability that I'm selecting the point in the region A to A dash, it is going to be equal to half, because A dash is the diameter. Remember, A dash is the diameter. So A dash is the diameter. So if I select the probability in the circumference A dash, either in the first half or in the second half, that is the half. Okay. Now, probability that I am selecting the point in the region B to B dash. Okay, arc B to B dash, or I am saying arc A to A dash. This is also equal to the, or you can write down if there is confusion like this one. Probability in the region arc A to A dash, it is going to be the same as probability in the region arc A dash to A. Okay, that is equal to half, because A dash is the diameter. Similarly, BB dash is the diameter. So probability of selecting the arc from B to B dash or from B dash to B. You can take clockwise or anti-clockwise, it doesn't matter, that is equal to half. Any doubts to anyone? So what is the probability that I've selected the point in the region A dash and I've also selected the point in B dash? Can you say that is going to be half into half, which is equal to 1 by 4? Okay, that is equal to 1 by 4. So what is the required probability? 1 minus 1 by 4. There is a 1 by 4 probability that will never get the 3 points are not a part of a series. So 1 minus 1 by 4, which is equal to 3 by 4. And this is answer. So any doubts to anyone now? Please tell me. Is that clear to all of you? Now, in general, you can remember this also, a general result for this question. In general, for n points, the answer is always equal to n upon 2 raised to power n minus 1. If you are selecting n points, and the probability that all these n points lies within a semicircle, that is always given by the formula n upon 2 raised to power n minus 1. We can generalize it also. So can I move to the next slide? Minus 1 is in the power of 2. Can I move to the next question? Please tell me now. Try this, question number 23. Anyone who can tell me the answer? Okay, let's see. 4 by 5, 1 by 16. All right, we'll check that. Just wait. Okay. Now it says point C is chosen at random, atop a 5 by 5 foot square table. So there is a 5 by 5 foot square table. So let me select a 5 by 5 foot square table. Okay. A circular disc within a radius of 1 foot is placed on the table with its centers directly on point C. What is the probability that the entire disk is on the top of the table? Now we need the entire disk is on the top of the table. All right, so I'll say, let's say this is a circle. Entire disk is on the top of the table. Okay, I've drawn a couple of circles here. All the diameter, how much? 1 foot. Now tell me one thing. Do I need to consider this case? Yes or no? Please tell me. Do I need to consider this case? Look at the figure and tell me yes or no. Am I audible? Yes. Now can I consider this case, this particular figure? No. It has to be completely within like this. Okay. So if I say if it has to be completely within like this one, so even this is allowed, even this is also allowed, and this is also allowed. Okay. So can I say for this to happen, that is only possible if the center of all these circles, if I take these points, just a minute. A figure has to be completely inside the square. So if I draw it something like this one, so can I say this radius of this circle is 1, so this length is equal to 4 unit, 4 unit, 4 unit, and 4 unit? Yes or no? As the radius of this figure is equal to 1 unit. So radius is 1 unit, so I can say this length it is equal to 1 and 1. Isn't it? This length it is equal to 1 and 1. Okay, this length is it is equal to 1 and 1. So if the center of the circle, if the center of the circle is lies inside this region, if the center of the circle will lies inside the region, then only can I say the entire circle will be always within the square table. Please tell me yes or no. If the center will be going outside, if you try to push the center outside the region, it will cross the square table. Is that part clear to all of you? Please tell me yes or no. Okay. Let me draw a few more circles here like this. Okay. Something like this. Yes, sorry, it is not 4, but क्या हो जाएगा? This has to be equal to 3. Perfect. Not 4, it is equal to 3. So any doubts to anyone? Please tell me now. So this would be 3, 3, and 3, and 3. So what is the probability? Probability is equal to nothing but 3 square upon 5 square, which is 9 by 25. And that is the answer. So if there is any doubt, please ask me now. How 3? Nikita, tell me one thing. ना ये चीज यहाँ से if I subtract 1 from here, subtract, okay, ठीक है. So the total length will be 3. So any doubts to anyone else? Ankur, Tanya, Vedanshu, Sameer, Rohan, Nikita, Mugdha, Madhur, Isit, Garima, and everyone? No. Okay. Now, try to solve one more question, which was asked in XAT 2018. Try this, all of you. And believe me, this the question which I have discussed 23. I have been discussing that question since long time. Maybe I don't remember. Maybe from 2004 or 2000. Similar question was asked in XAT 2018. Yes, that's right. What is the answer? All of you, please tell me. That's right. Option number 5. Perfect. Any doubts to anyone now? Mhm. Because the radius is equal to 3. So I can say the total length here, it is nothing but that is going to be equal to 10 centimeter. This is 10 and this is 10 and this is also 10 and this is 10. So this length, it is equal to how much? This is 3. This is also 3. Radius is 3, so 3 and 3. So this length, it will be comes out to be coin of radius 3 centimeter is randomly dropped down a square floor of square tips of side 10 each. So 3 plus 3, 6. So this will be equal to 4 unit and 4. So the answer is 4 square upon 10 square, which is equal to 0.16. That is the answer. So any doubts to anyone now? All right. So let's stop here, and tomorrow we'll continue with the geometric probability, few more questions, and then we'll move to the conditional probability. Okay? So any doubts to anyone now? Alright, guys. So good night to all of you. For NMAT strategy, तो अभी we'll talk about that later on. ना? It's अभी काफी time है. Alright. So good night, guys. See you all tomorrow. Good evening, everyone. Can you all hear me? Please respond. Alright. So let's start with the today's session, the last session of probability. Alright. So we'll continue with the geometric probability. Try this, all of you. Suppose there are two numbers x and y are chosen such that x is lying in the range 0 to 1 and y is lying in the range also 0 to 1. So what is the probability that x plus y is greater than 3 by 2? Please try, all of you. What is the probability that x plus y is greater than 3 by 2? Now if you look at here, the value x and y, they are lying in the range 0 to 1. Okay. So I'll say I'll plot a graph, x axis and y axis. Okay. So this is the x axis and this is y axis. So this is x and then this is y and 0. Now both x and y are lying in the range 0 to 1. Okay. So x is lying in the range 0 to 1. So I can plot a line 0 to 1. Alright. So let's say this is the line. I'll say this is the line which is equal to what? Y equal to 1. Okay, this point is y is equal to 1. So I can say this is the line y is equal to 1. Alright. And then x is equal to 1. So this is the line which says that x is equal to 1. So this is 1. So this point is nothing but that is 1 comma 1. So can I say the two numbers are there such that x is lying in the range 0 to 1 as well as y is also lying in the range 0 to 1. So both of them are lying in the range 0 to 1. So if both of them are lying in the range 0 to 1, so my sample space or the all the possible outcomes, it is nothing but that is going to be the area of this region. Please tell me yes or no. In this region, the value of x will always be between 0 to 1 as well as y will be also between 0 to 1. But what is the question? The question is probability that the x plus y is greater than 3 by 2. So x plus y is greater than 3 by 2. 3 by 2 is equal to 1.5. So I can plot a graph of x plus y is equal to 1.5. So if I plot a line x plus y is equal to 1.5, maybe it will be like this one, something like this. Okay. So this point I can say, let's say this is equal to 3 by 2. Okay, this is 3 by 2 and this point is also 3 by 2. Now x plus y is greater than equal to 3 by 2. So if it is greater than equal to 3 by 2, which region I need to take? The left hand side of this line or the right hand side? In which region x plus y is greater than 3 by 2? Please tell me. On the left hand side of this line or the right? Yes. So on the right hand side of this line. So on the right hand side of this line, x plus y is nothing but it is always like this region. Okay. In this region, x plus y is always greater than 3 by 2. Okay. So I can say it will be always around this region here. So basically we need to find out the area of this green region. Yes or no? That is going to be my numerator. Okay. So that is going to be my numerator here. Alright. So now tell me one thing. Okay. So can I say the probability, the required probability, it is nothing but that is equal to what? Area of the square which is 1 into 1. And in the numerator I need to find out the area of the triangle. So area of the triangle. What is the area of this triangle? I can say this point is this is nothing but that is equal to half and this is equal to half. So what is the area of this green triangle? Half into base into height. So base is again half and the height is also equal to 1 by 2. So the probability will be 1 by 8 and that is the answer. So any doubts to anyone in this question? Please tell me now. Siddhant, Aditi, Avinash, Bhumika, Garima, Isit, Jatin, Madhur, and everyone. All right. So can we move to the next slide now? If this part is clear to all of you. Try this. Similar question was asked in the XAT also. It says, my friend and I are hoping to meet for lunch. We'll each arrive at our favorite restaurant at random time between noon and 1 p.m. and stay there for 15 minutes, then leave. What is the probability that we'll meet each other while at the restaurant? For example, if I show up at 12:10 and my friend show up at 12:15, then we'll meet because the time difference between these two is 5 minutes. On the other hand, if I show up at 12:50 and my friend showed up 12:20, so there is a gap of 30 minutes. But anyone can wait maximum for 15 minutes. Then they will miss each other. So what I can say, let's say one of the friends arrive at a time which is 12x, 12 o'clock and x minutes, and the other friend arrive at a time which is 12 o'clock and y minutes. Now, under what conditions they can meet? Can I say they can meet only if the time gap between these two is less than equal to 15 minutes? Yes. So that is going to be mod of x minus y less than 15. Either x minus y is less than 15 or y minus x is less than 15. So I can say mod of x minus y is less than 15. So now let's again plot the graph. So if I try to plot the graph like this, okay. So this is x-axis and this is y-axis. Okay. Now both of them have started at a 12 and the time limit is 1 o'clock. Okay. They will arrive till 1. So just give me a minute. Okay. So this is 12 p.m. and this is nothing but that is 1 p.m. and this is 1 p.m. Okay, I can say let me that is 12:10, 12:15, 12:20 and something like that. Okay. Now they will meet each other only if the time gap is this one. Okay, this total it is equal to nothing but that is 60 division. In 1 hour total is 60 minutes. So 12 p.m. and this is 1 p.m. This is also 1 p.m. So the total gap is of 60 divisions here. Now I need to plot the graph for mod of x minus y which is less than equal to 15. Okay, so let's plot here. So this and this. Okay, so mod of x minus y it is less than equal to 15. So which reason I am talking about? The reason which is between these two. The time gap between these two it has to be less than equal to 15. Okay, so this shaded region is the area which represents that mod of x minus y which is less than equal to. Now we know that Garima that they can meet each other only if the difference between these two times is less than 50. So plot the graph of mod x minus y less than 50. So this is the graph which I plotted. That is the graph of mod of x minus y less than 15. Or it can be even equal to, you can say, doesn't matter. that is equal to 15. Is that clear now? Shaded region, Garima, I have discussed that in algebra. Na? Plot the graph of mod of x minus y is less than equal to 15. कैसे plot करते हैं? First, I need to plot the graph of x minus y is less than 15. So mod of x minus y, it will be equal to x minus y or y minus x, or it basically means that it will lies in the range minus 15 to plus 15. Na? So go for the test. Just here whether origin satisfies this region or not. So if I put here origin at 0 and 0, you can see that the origin is satisfying here. Am I audible to all of you? Please respond. Can you all hear me? Breaking. I don't think ऐसा तो कोई issues नहीं है. Please respond. Am I audible? I don't think there is any issues here. All right. So I need to plot the graph of mod of x minus y less than equal to 15. So the graph बनाने में problem है. Plot the graph of x minus y is equal to plus 15 and x minus y is equal to minus 15. So x minus y equal to plus 15 and x minus y equal to plus 15, and take the region between these two. So I'll get the graph of this particular region. Is that clear now? Okay. Now, this is what? This is 15. Okay, it will set it at 15. All right. This is also nothing that is going to be 15. And this will be 45 and this will be 45. Okay. Like this. All right. So now, and you can see also observe where the gap has to be 15. So here at every point there is a gap of 15, like here to here. This is 15 minutes, isn't it? So this is 15 and like this 15. Okay. Now, so in the total area it is equal to 60 into 60. Is that part clear to all of you? Total area it is equal to 60 into 60. Just wait for a second, all of you. Am I audible? Please respond. Yes. So can you say the total area it is equal to 60 into 60. Now I need to find out the area of the said region. So what is the area of this triangle? So can I say that the area of this triangle it is equal to half into 45 into 45? Please tell me yes or no. Half of 45 into 45. So the area of the shaded region is equal to area of the square minus, there are two triangles. Okay. For both the triangles, the area is half of 45 into 45. So 60 into 60 minus half into 45 into 45. If you solve this, you'll get the answer as 7 by 16, and this is the answer. So any doubts to anyone now? Please respond. So this same question was asked in XAT also in one of the year. Can I move to the next slide? Try this, question number 3. Now just here. GAIL is operating a small air freight delivery service. Every day, she travels from her home base to another city and back. The city she flies to all are less than 200 miles. So the city is nothing but it is less than 200 miles from her home base. Every morning, GAIL puts enough fuel into her small plane to fly 450 miles. Okay, all right. This morning, GAIL is distracted by a miner. Now, so what I'll say, there are two things. So I'll say there are two axes again, x-axis and y-axis. So this is x-axis and this is y-axis. This is a mileage for today. On any particular day, she has got a fuel so that uh, it says the city she flies to are all less than 200 miles. Okay. Every morning, GAIL puts enough fuel into her small plane to fly 450 miles. Okay, so you can fly 450 miles. So maximum distance she can travel on any particular day is how much? 400. Isn't it? 400. All right. So, and then I'll write down that is mileage for yesterday. So mileage for today and the mileage for yesterday. Okay. So we know that all the distances are nothing but they are less than or equal to 400. Because the cities she flies to are all less than 200 miles. So on any particular day, she can travel how much distance, Jatin? Can you tell me? Maximum how much distance she can travel? 400. So that's why we need to take 400. Clear now? So mileage for any particular day, the maximum it can be equal to 400 and the minimum also, uh, this is 400 and 400. So can I say the maximum distance which she can travel today, it is 400 and the maximum distance which she can travel yesterday is also 400. So I can say that is equal to 400 and this is also 400. Okay. Now, every morning, GAIL puts enough fuel into her small plane to fly 450 miles. Okay. The This morning, GAIL is distracted by a minor repair to her plane and forgets to refuel. What is the probability that she will run out of the fuel during her flight today? Now, can I say she will run out of the fuel today if the total distance traveled yesterday, that is on the x-axis, sorry, today, plus the total distance which she has traveled in the yesterday, that is y, if it is more than 450? Yes or no? If it is more than 450, the total distance, then only she will run out of the fuel. So can you plot the graph of x plus y greater than 450? It will be like this. This is 50, okay, 450, and this is 450. So can I say she will run out of the fuel if in this particular region? Please tell me yes or no. गरीबा क्वेश्चन नहीं पढ़ते हो तुम लोग ना. GAIL Post is operating a small air freight delivery service. Every day she travels from her home base to another city and back. The cities she flies to are all less than 200 miles from her home base. Every morning, GAIL puts enough fuel into her small plane to fly 450. This morning, GAIL is distracted by a minor repair to her plane and forgets to refuel. So she didn't refuel today. Then only there can be question if she has refueled it, तब तो probability का question बनेगा ही नहीं ना उसमें. Then she will never run out of the fuel. She can always come back. Is that clear? So yesterday it was fueled. The tank was full. So she can travel only the maximum 450. So can I say she ran out of the fuel if the total distance traveled by her yesterday plus today it will be more than 450. So now I need to find out the area of this particular stated reason. Let's say this is equal to 400 and this is also 400. What is this line? This point will be equal to 50, isn't it? So this is 400 and this is 50. Why? Because this distance is 50. Okay. So this is a 50. So this will be also 50. This is a right angle triangle. So this will be 50 and 50. Okay. So this distance is basically 350. Similarly, this distance is also 350. All right. This point is x-axis is 50 and the y-axis is equal to 400. Any doubts to anyone now? So the probability, it will be equal to the total area, it will be equal to 400 into 400. Okay. And half of base into height. What is the area of the triangle? 350 into 350. So it will be comes out to be 49 by 128. And that will be the answer. So now tell me if there is any doubts to anyone. Please respond. So can I move to the next question? Try this. It says a line segment is 8-inch long. So there is a line segment and the length of this line segment is 8 inches. 2 points are put on the segment at random locations. So I put a 2 points at the random location. Let's say this is the first point and the second. What is the probability that the three segments formed by the 2 points will make a triangle? So let's say the first part, the length of the first segment is x, the second segment is y, so the third segment will be equal to 8 minus x minus y. Okay. So I'm getting a three segment that is only possible if all the three parts, that is x should be greater than 0, y should be also greater than 0, and 8 minus x minus y is greater than 0. So this implies 8 minus x minus y is greater than 0, so it means x plus y, it is greater than 8. Okay. So this is the condition under which we'll get a three different line segments. Is that part clear to all of you? For dividing a line into three segments, one of the segments should be positive, another segment should be positive, and the sum of these two lengths, it has to be less than 8. 8 greater, yes, of course, ना solve कर लो इसे क्या आएगा solve करके. All right. Now, what is the probability that the three segments formed by 2 points make a triangle? Now, what is the property of a triangle? That sum of any two sides, it has to be greater than third side, isn't it? Sum of any two sides, it has to be greater than third side. So I can say the sum of two sides, that is x plus y, it has to be greater than 8 minus x minus. So this implies that x plus y, it has to be more than other two sides, that is x plus 8 minus x minus y. Sum of these two sides, it has to be greater than the third side y. So from here I'll get that the value of y, it is less than 4. And the sum of other two sides, that is y plus 8 minus x minus y, it has to be greater than x. So from here I'll get x is less than 4. So what is the conditions for getting a triangle? This is the condition for getting a triangle. Okay. And this is my all the possible cases. So now let's plot the graph. All right. So if I try to plot the graph, that is x-axis and the y-axis. Let's plot the graph of this, my sample space. X is positive, y is positive. So x is positive, y is positive means I am talking about the first quadrant. And x plus y is less than 8. So x plus y is less than 8. Okay. So let me write down this is equal to 8 and this is okay. So can I say this is the reason, this is my all the possible outcomes, yes or no? All the possible values of x and y, it will lies in this range. Please tell me yes or no. In this reason, x is positive, y is positive, and x plus y is less than 8. Now, under what conditions we are getting a triangle? This is the condition, which says x is less than 4 and y is less than 4. Okay. So x is less than 4, y is less than 4. So let me plot the line. X equal to 4 and y is equal to 4. Okay. So this is the line 4. Y is equal to 4 and x is equal to 4. So x equal to 4, y equal to 4, I have plotted. And x plus y is also greater than 4. So I'll plot the line x plus y. Sorry, it is greater than 4. So this second line which I have drawn, this one, the black one, it is nothing but x plus y equal to 4. But it has to be greater than this one. So greater than this one, so means what? I'm talking about this. Yes or no? This green region. So what is the area of this green region with respect to the entire bigger triangle? So I'll say the area, this entire figure, it has been divided into 4 triangles of equal areas, yes or no? It has been divided into the 4 triangles of equal area. So what is the probability? The probability, it is equal to 1 by 4. And this is the answer. Okay, that is the green region. Do I need to calculate the area or it's clear? All the 4 areas, it must be equal because it's a midpoint. Isn't it? This is 8, this is 4. So we know that midpoints, whenever I join the midpoints in this way, the area will be always divided into the 4. All the 4 areas will be equal. So the probability will be 1 by 4. Any doubts to anyone now? Please respond. So can I move to the next slide if this part is clear to all of you? Try this. Question number 5. Oh, yes, that's right. A point is chosen uniformly at random from the interior of a sphere. What is the probability that it is closer to the center of the sphere than it is to the surface of a sphere? So I'll say this one. This is a sphere. And a point is chosen uniformly at random from the interior. What is the probability that it is closer to the center of the sphere than to the surface of the sphere? Okay. So I'm drawing this another circle, a sphere like this. Okay. So let's say the radius of the inner one. Radius of the inner sphere, it is equal to 1. And the radius of the outer, it is equal to 2. The figure is not drawn to the scale, that is equal to 2. Okay. So can I say in this case, if my point lies within this region, then only it will be center to the, it will be near to the center of the sphere, yes or no? Please tell me. If I assume the radius of the innermost sphere, that is 1 and this is equal to radius of this bigger one is 2. Again, the figure is not drawn to the scale, just keep this in mind. So if it is closer than this one. So what is the volume of a hemisphere, or sorry, volume of a sphere? that is 4 by 3 pi r cube. So pi into 2 cube. Sample space, because I can take a point anywhere in the sphere. But since it has to be closer to the center, so it must lies within this blue sphere. So the volume of the blue sphere is 4 by 3 pi into 1. So the answer will be equal to 1 by 8. And that is. So now tell me if there is any doubts to anyone. Siddhant, Aditi, Anupam, Avinash, Bhumika, Garima, Isit, Jatin, Madhur, Meher, Mohit, Mukta, Nikita, Avijit. Everyone. So can I move to the next slide? Now next thing we'll talk about, that is expected value. Important for that decision making section. Okay, a very simple topic, expected value. Now let me define that. What do we mean by the term expected value? Now you are probably already familiar with the concept of mean or average. For example, if there are three numbers 5, 8 and 14, their average is 5 plus 8 plus 14 by 3, which is equal to 27 by 3, which is equal to 9. More generally, if we are given numbers like x1, comma x2 and so on till xn, then their average, often denoted x bar, is this. If we extend the concept of average to the outcome of a random event, we get what is called expected value or expectation. So expected value is the term we use to indicate the average result. Basically, it's the average result we would expect to get if we did a large number of trials for any experiment. Essentially, expected value is the weighted average, in which the more likely the outcome, the more that outcome is weighted. Can I move to the next slide? Now, let me take an example. Let's look at a simple example. Suppose that we are flipping a coin. If we get head, we win $2. But if we get a tail, we lose $1. So if we flip the coin 1000 times, we would expect to get head 500 times and tail 500 times, equal chances there. So we would win a total of $1000 from our 500 head. For every head we are getting $2. So for 500 head, we will be winning 500 into 2, that is 1000. And lose a total of 500 from our 500 heads, because we are losing $1 for one tail. So if I am getting tail 500 times, so we will be losing 500. So for a total net profit of 1000 minus 500, that is equal to 500. And since the profit is realized over the course of 1000 flips, our average profit per flip is 500 upon 1000, which is 0.5. And this is known as the expected value. Is that clear to all of you? Please respond. So we say that the expected value of each flip is 0.5. In this case, since head and tail are equally likely, the expected value is just the usual average of the two outcomes. Okay, that is $2 plus minus $1 by 2, because there is an equal chances of getting head and tail. So the answer is 0.50. Can I move to the next slide? Please tell me. Okay, now again read here carefully all this time. So suppose that we have an event in which every outcome corresponds to some value. For example, if I'm throwing a dice, so I'm throwing a dice, there are 6 possibilities. Okay, so I can say the value x1 occur with the probability p1, value x2 occur with the probability p2, and so on. So the sum of all the probability, it is equal to 1. So expected value is equal to probability of 1 into x1 plus probability of 2 into x2 and so on till probability of n into xn. So this is the expected value. Okay, like in the coin question, probability of getting a head is 1 by 2. Okay, probability of getting a head is 1 by 2, and for every head we are getting return of $2. So 1 by 2 into $2 plus probability of getting a tail is 1 by 2, and for every dollar we are getting a For every tail, we are losing -1, so -1. So that's why this is 0.5. So this is how we define the expected value. Is that part clear? Please respond. Let me take a couple of questions here so that you can understand this. Tell me the answer of this. What is the expected value of the roll of a standard six-sided die? Okay. Now we know that the expected value it is equal to probability of 1 into x1. That is probability for the second event to the x2 and so on. Probability for the third event into x3 and so on so forth. So I can say expected value it is equal to probability of getting 1 it is 1 by 6 into 1. Let's say x2 is the event of probability of getting 2. So probability of getting 2 is 1 by 6 into 2. Probability of getting 3 is 1 by 6 and I'm getting a 3 so into 3 plus probability of getting 4 is also 1 by 6 so into 4 and probability of getting 5 is 1 by 6 into 5 and probability of getting 6 is 1 by 6 into 6. So this value it will be comes out to be 3.5 and this. So this is the expected value. Is that clear to all of you? Try this then. This is if you flip. What is the answer? Easy one. Yes, that's it. Probability of head. It says suppose you have weighted a coin in which the head comes up with a probability 3 by 4. So probability that I'll get a head is 3 by 4 and whenever I'm getting a head I will win $2. So 3 by 4 into $2. Probability of getting a tail it is equal to 1 by 4 and whenever I'm getting a tail I'm losing my $1 so into -1. So expected value is equal to 5 by 4 and this is the answer. Any doubts? Can I move to the next slide? Try this question number 8. What is the answer? Now probability of getting red. Yes, probability of getting red is how much? Out of 20 marbles, 2 of them are red. So 2 by 20. And if I get red, amount 1 is 10. So plus 10 plus. Probability of getting yellow, it is equal to 3 by 10. And in return, I get $5. So into 5 plus. Probability of blue, it is equal to 4 by 10 into $2. Probability of getting green, it is equal to 5 by 10 into $1. And probability of getting black, that is 6 by 20. Oh, in the denominator, it has to be 20, not 10. So there are total of 20 marbles. So 3 by 20, 4 by 20, and 5 by 20, and 6 by 20 into 0. So what is this value coming out to be, all of you? 12 by 5. That's right. This is the answer. Any doubt? Can I move to the next slide? So once you understand the definition, it's a very easy topic. Try this question number 9. It says, suppose I have a bag with 12 slip of paper in it. Some of the slips have a 2 on them and rest have 7. If the expected value of the number shown on a slip randomly drawn from the bag is 3.2. Okay, how many slips have a 2? So let us assume number of slips with 2 written on them, it is equal to x. So I can say number of slips with 7 written on them, that is going to be equal to 12 minus x, as total number of slips is x. So probability of getting 2, that is x by 12. And whenever I am getting 2, I'll get how much return? That is 2. That is 2 plus probability of getting 7, that is equal to 12 minus x by 12 and into 7. And this is equal to 3.25. So just solve this equation, and I think that's right. The answer is definitely 9. So x is equal to 9. Any doubts to anyone now? Please respond. No? So can I move to the next slide? Try this, question number 10. Okay. Now you are playing a game in which the prize pool start at $1. On every turn, you flip a fair coin. No. If you flip head, then the prize pool doubles and the game continues. If you flip 10, then the game ends and you win the prize pool. What is the expected value of your win? So now I can get a 10. Okay, the game ends. Or first I'll get a head, then 10. Or I'll get a head, then again head, and then 10. Or again I'll get a head, or head, or head, or 10. Or so on. So probability of getting 10, it is 1 by 2 and into 1. Or plus probability of getting head 1 by 2, tail is 1 by 2, and then it will be amount will be double. Okay. Or plus I can say this is equal to what? 1 by 2. Just a minute. So this is 1 by 2 into 1 plus 1 by 2 into 1 by 2 into 2 plus. Now next is 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. And then multiply it by 4 because amount will keep doubling. Alright. Then I'll say again 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. Alright. And so on. I think I'm writing something wrong. Just wait. 3 times आएगा ना पहले? Yes. 4 times I've written. Let me make a correction here. 1 by 2 into 1 by 2 into 1 by 2 into 4 plus 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 and then that is 8 and so on. So this value it is 0.5. The second value is also 0.5. Third is also 0.5. Fourth is also 0.5. Fifth is also 0.5. And it will goes on till infinity. Yes or no? So what is the final answer? That is infinity. So expected value of your evening it is that is infinite. Is that clear now? No, we can't say GP with the ratio 1. You can say GP with the ratio 1 or it's a AP with a common difference 0. You can give it as anything, but it doesn't matter. It's a simple series which will continue. So the answer is infinite. Clear now? Can I move to the next part? Coming to the most important part of the probability, that is conditional probability. And very important also. So now let's see. As the name suggests, conditional probability is with some addition added restriction. For many of these problems, we can use our usual method of computing probability. That probability of event is equal to number of successful outcomes upon number of possible outcomes. But the main difference with the conditional probability is that the number of possible outcomes is usually restricted by some condition. Let's take an example here. Try this and tell me the answer. A fair six-sided die is rolled. If we know that the result is an even number, then what is the probability that we rolled a six? Now, what is the condition here? There is something which we know. If we know that the result is an even, okay, the result is an even. So if the result is even, this is something which you are already aware. So can you say that is 2, 4 and 6? So this is my possible outcomes. This is my possible outcome. So instead of taking my outcome as all the 6 numbers 1, 2, 3, 4, 5, I guess these are the only possible outcomes. Then what is the probability that we roll the 6? So out of these 3 numbers, there is only one is 6. So the answer is equal to 1 by 3. And this is the answer. Any doubts to anyone? So instead of taking the sample space as 6, we can say there are 3 possibilities. And among these 3, that there is only one case of getting 6. So the answer is 1 by 3. So conditional probability is not a mysterious. If all events are equally likely, it's just that the number of successful outcomes upon number of possible outcomes. The only difference is that the condition might change the number of possible and successful outcomes. Otherwise, the same thing we need to use it here. Try this. two fair six-sided dice are rolled. If at least one of the dice shows 3, then what is the probability that the sum of the two dice is 7? Let's see here. It says, what is the probability that if at least one of the dice is showing 3. So at least one of this dice is showing 3. So first dice can show 3. Okay. And if the first dice is showing 3, the other possibility is that the second dice can show 1 or 2 or 3 or 4 or 5 or 6. If the first dice is showing 3. Or if the second dice is showing 3, the first number can be 1, 2, 3, 4, 5, 6. So that is 2, 3, 3, 3, 4, 3, 5, 3, and 6, 3. So how many cases are there? Can I say there is one case which has been counted twice here? Yes or no? That is 3 and 3. So what is the total number of possible outcomes? Is it going to be equal to 12 or 11? Number of possible outcomes. So the number of possible outcomes, that is going to be equal to 12. Then what is the probability that the sum of the two dice is 7? So out of these 11 cases, in how many of the cases the sum is 7? I think there is only two cases, 3 plus 4 and 4 plus 3. So what is the answer? That is 2 by 11. Okay. Number of possible outcome is not 12, but it is 11. So there are 11 possibilities, and out of these 11 cases, in only 2 of the cases, the sum can be 7. So the answer is simply 2 by 11. Any doubts to anyone now? No. So can we move to the next slide? Try question number 30. All of you. Okay. 3 coins are flipped. If at least one of them comes up head, then what is the probability that all come up head? So I need to find out probability that all are showing head given, what is the condition? Given at least there is one head. Okay. So I'll say this is equal to, the given condition is that there is at least one head. So I can say in the denominator it has to be number of ways to have at least one head. At least one head. If there is at least one head, then what is the probability that all of them are ways? So number of ways to have all heads. This is what I can write it down in this way. Now, if the 3 coins are flipped, what is the total possibilities? How many cases are there? If the 3 coins are flipped, can you say 8 possibilities? The first coin can show either head or tail. Yes or no? The first coin can show either head or tail. Yes or no? Or the second coin can show also head or tail. The third coin can also show head or tail. So the total possibility is nothing but that is equal to 2 into 2 into 2, that is 8 cases. Out of these 8 cases, there will be exactly one case in which all the 3 are showing the tail. Yes or no? So in how many of the cases there is a minimum of one head? Can I say 7? Okay. Total 8 possibilities, and there will be only one case in which all the 3 are showing tail. So there will be exactly 7 cases in which at least one of the coin is showing head. But what is the probability that all of them are head? So out of this, there will be exactly one case in which all of them are showing head. So the answer is 1 by 7. And this is the answer. Any doubts to anyone now? Please respond. Can I move to the next slide? Try this. Question number 14. So it says box X has two red balls. Okay. So there are two boxes. Let's see. So box X, it has got two red and three blue. Okay. Bag Y, it has got 8 red and 2 blue. One of the two bag is chosen at random, and then a ball is chosen at random from that ball. If a blue ball is chosen, what is the probability that it comes from bag X? Now, first of all, let's do step by step. I write down one thing here: probability of drawing a blue ball. Probability of drawing a blue ball. Can anyone tell me what is the probability of drawing a blue ball? 2 by 5. Okay. The blue ball, I can draw it either from bag X or bag Y. There are two possibilities. So first of all, the selection probability that I'll select the bag X, it is equal to half. And from that bag, I'm picking the blue ball, that is 3 by 5. Or I select the bag Y. So probability that I'll select the bag Y, it is half. And from there, the probability of getting blue, that is equal to 2 by 10. And if you solve this, it is coming out to be 2 by 5. Have some of your points. If there is no restrictions, if the question is simply what is the probability if one ball is drawn, what is the probability that is the blue color? The answer is 2 by 5. Now tell me one thing. Probability of drawing a blue ball from bag X. What is the probability that I draw a blue ball from bag X? 3 by 10. Bag X. So same logic, I can say that probability that I select a bag X, that is going to be equal to half. And from that bag, I am selecting a blue ball, that is equal to 3 by 5. So the answer is 3 by 10. Clear now? Probability that I select a bag X, that is half, and into 3 by 5, which is 3 by 10. Any doubts for anyone? Please respond. Now the question is saying here, if a blue ball is chosen, that is the condition. If a blue ball is chosen, what is the probability that it came from bag X? So I need to find out probability that bag X gives blue ball if blue ball is selected. Okay. So can I say out of these two parameters, which part will come in the denominator? Now there is an event which has happened in advance, the possible outcomes. The question is that if a blue ball is chosen, so blue ball is chosen, so we know that the probability of drawing a blue ball is 2 by 5. So can I say in the denominator it will be equal to nothing but that is 1 by 2 into 3 by 5 plus 1 by 2 into 2 by 10. If a blue ball is chosen, so the possible outcome is that is nothing but the blue ball is chosen, so that is the possible outcome. and the successful outcomes that it is from bag X. So that is equal to this one, which is 1 by 2 into 3 by 5. So if I solve this, it will be comes out to be how much? Can anyone tell me? 3 by 4. And this is the answer. So is that part clear to all of you? Please respond. Now, so one thing which I'll define here, that is, so probability of some event given under some condition, given under the some condition, it is equal to probability. Denominator is nothing but the probability under that given condition. In the numerator, probability of that event and that particular condition. So you can see here in the denominator, it says if a blue ball is present. So the possible outcome is the blue ball, which I have calculated it here. Yes or no? Then what is the probability that it came from a bag X? So blue ball from bag X. So you can see this particular portion 1 by 2 into 3 by 5. It is in the denominator as well as in the numerator. And this particular theorem, it is known as what? Bayes theorem. So Bayes theorem is nothing but it is basically a conditional probability. Any doubts to anyone now? So name is not important. So how will we represent this? It is represented in this way. Probability of A by B. So probability of A by B means probability of happening of event A if event B has already occurred in advance. I'm repeating, happening of event A if event B has occurred in advance. It is equal to, in the denominator, B has happened in advance, so probability of B. And in the numerator, it will be probability of A intersection. And like I told you, it's not necessary to memorize these formulas. Is that clear? Can I move to the next slide? Try this. Okay, now this here. There are 5 men and 7 women in the lawn bowling club. 2 members are randomly chosen to go to the state. During the press conference after the selection, a reporter asked the president of the club if at least 1 woman was selected, to which president replies yes. So what is the event which is happening in advance? What is the probability that both are women? So we need to find out probability both are women, if there is at least 1 woman, yes or no? This is something which has happened in advance because the president replies yes, there is at least 1 woman. So if there is at least 1 woman, then what is the probability that both are women? So this is going to be equal to what? In the denominator, probability that there is at least 1 woman. And in the numerator, I can say probability that both are. So both are women. It will be going to be 7C2. And at least 1 woman. So total 12 persons are there. 5 plus 7, 12. So I can say 12. Okay, C2 minus subtract the cases in which there is no women. If there is no women, it means there is at least 1. So I'll subtract 5C2. So this is the answer. Any doubts to anyone now? Please tell me. So you can solve it, Nikita. You'll get the answer. I don't know what is the exact answer. Can I move to the next slide? Please tell me. All right. So let's move to the next question. Try question number 6. Okay, let's see. The CDC has developed a new test for a boogie woogie. Unfortunately, the test is only 90% accurate. 10% of the time, it gives a wrong result. It says a person is infected when he is healthy, or it says a person is healthy when he is infected. Suppose that 5% of the general population has the flu. If a person tests positive for the flu, what is the probability that he actually is? Now, what is the condition here? If a person tests positive for the flu, this is the condition. What is the probability that he has it? So let me represent it this way. Probability of A by B. That is always equal to probability of A intersection B upon probability of B. Now, what is B here? B is the event which happened in advance, that a person tests positive. So I can say B is here, that the person tests positive for the flu. And what is A here? That person, what is the probability that he has actually it? That the person actually has. Any doubts to anyone till this step, please respond. Mohit, Meher, Madhur, Jatin, Ishit, and everyone. All right. Now, so let's calculate B first of all, probability D. Probability that a person tests, okay, D is nothing but person that tests positive for the flu. अब इसमें दो केस होंगे. The person has flu and tested positive, or person does not have flu, the person don't have flu, but still that person has been tested positive. Nothing question में given है ना, if a person tests, so something, when I say A by means what? Probability of happening of event A if event B has already occurred in advance. So can you tell me what is the event which has happened in advance? क्या पहले हुआ है कि उसको फ्लू है या टेस्ट पॉजिटिव है? So that's why the person test positive for the flu, that is B. Then what is the probability? I need to find out this is the probability. So that is the A. Clear now? Now, person has a flu and tested positive. Now, person has a flu. Suppose that 5% of the general population has the flu. So person has a flu, so 5%, so I can say 0.05. And then it has been tested positive. That is 90% because the test is 90% accurate. So into zero point 0.9 plus person don't have a flu. 5% of the people have a flu, 95% people doesn't have flu. So that is 0.95. And 10% of the time it gives a wrong result. So can you say it doesn't have a flu, but he has been tested positive, and in 10% of the cases it gives a wrong prediction. So into 0.1. So is the value of probability of B clear to all of you? Please respond yes or no. I'm writing down step by step. Now I need to find out the probability of A intersection B. So tell me in the A intersection B whether I should take the first part or the second part. That the person actually has a flu. Actually has a flu, that is 0.05 into zero point 0.9. So A intersection B is 0.05 into zero point 0.9. So what is the answer? That is 0.05 into zero point 0.9 and upon 0.05 into 9 plus 0.95 into zero point 0.1, which is equal to 9 by 20. And that is. So it's a very standard question. I'm sure that you all have gone through such type of question in class 11th, isn't it? NCRT book. Even this question, I think I have picked it from the NCRT book. 11th or maybe 12th. Probably started in class 10th only. Yeah, some basics. Can I move to the next question? Try this. Question number 70. Okay, let's see here. Richard runs a blivet making factory. So he's making blivet. Unfortunately, due to circumstances beyond his control, 20% of the blivets that Richard makes are defective. So 20% of them are defective. Are defective. Okay. So I can say 80% are non-defective. Okay. Defective blivet fails 10% of the time. So defective blivet fails 10% of the time it fails. Alright. And you don't want to be around when the blivet fails. But good, non-defective blivet never fails. So this blivet never fails. How many times that Richard have to test a blivet that comes off his assembly line? in order for him to be 95% sure that the blivet is actually good. So I need to find out probability that a blivet is good. A blivet is good if the blivet passes n test, isn't it? Let's say if the blivet passes n test, how many tests are needed, isn't it? And this has to be more than equal to what? 95%. Is that part clear to all of you? It says how many times. So let's say it passes n times. Blivet, क्या होता है blivet? Yes, it is like a fork only. All right, it is like a fork only. Now, so it says a blivet. Okay, yeah. Can you all hear me now? So this is 20% are defective. Okay. A blivet is good if the blivet passes n test here. Okay. Now, if it passes the n test, so n test they are passing. What are the different cases here? The all the non-defective, that is 80% of non-defective, and it passes. The probability is what? Because it never fails. Plus 20% are defective, 0.2, and it passes 10% is the probability of fail. So the probability of it passing, it is going to be nothing but that is 90%. So into 0.9, and if it passes n times, then the raised to power n. Is that part clear to all of you? That if it passes n times, then I need to take 0.9 raised to power n. Any doubts to anyone? Please respond. Now, which part will come in the numerator? The first part or the second part? First part. Because a blivet is good. In that case, the second part is the defective one, but it passes the test. There is a 90% chances that it passes the test here. So I'll say that is 0.8 into 1. And this will be comes out to be more than equal to 0.95. And then we need to find out what should be the value of n such that it will be more than 0.9. So if we solve this, we will get n is approximately equal to 15. 1, 5. This is that. Any doubts to anyone now, please respond. So a difficult question, in fact. Can I move to the next slide if this part is clear to all of you? So in conditional probability problems, make sure that you properly identify what is the condition and what is the successful outcome. Don't just blindly jump into the calculations until you have first determined what it is you need to calculate. Now let's take few more questions on conditional probability. Try this. Okay. Now we have solved a similar question yesterday, isn't it? Valentini or Valentine and Naoki plan to meet at a restaurant for a lunch. They agree, in fact, today only, they agree that they will each separately shows up at random time between 12 p.m. and 2 p.m. They will each wait for 15 minutes. If the other shows up in that time period, they will have lunch together. Otherwise, they will leave. Today, Naoki showed up, waited for 15 minutes, and left because Valentine had not shown up. What is the probability that they would have had lunch together if Naoki had been willing to wait 15 more minutes? If she try to wait for the 15 more minutes. Now, let's see it here, how we can do it. So 12 p.m. to 2 p.m. So 12 p.m. to 2 p.m. So I can say 0 to 120 minutes. Yes or no? 0 to 120 minutes. So x-axis it shows the arrival time for the Naoki. Okay. And the y-axis shows the arrival times for Valentine. Write down only V. Okay. Arrival time for V. So both of them will wait for a maximum 15 minutes. So I need to plot a graph of mod of x minus y, which is less than equal to 15. Yes or no? So if I plot a graph of mod of x minus y less than equal to 15, so it will be like, okay, I am drawing it directly, and this is the gap here. Okay, this is the 15 minutes. Is that part clear to all of you? Please tell me yes or no. This middle part. But it says they will each wait for 15 minutes. If the other shows up in that period, they will have lunch together. Otherwise, they will leave. Today, Naoki showed up, waited for 15 minutes, and left because Valentine has not shown up. So today, they did not meet. So they did not meet. So what is the probability of the reason in which they did not meet? Can I say this is a sample space? Because they both waited for, okay, Naoki came and waited, but still they were not able to meet each other. So they were not able to meet each other. It means this is what I need to find out, area of this scenario. So this is a condition event which is happening in advance. Is that part clear to all of you? So in the denominator, my denominator, it will be nothing, but can you tell me what is its area? Twice of, half of. This is 15 minutes and this is 105. This is 15 and this is 105. So I can say half into base into height. No? So base is 105, height is 105. So this is the event which is happening in advance. That one person came, but still they were not able to meet each other. So what is the probability that they will not meet each other? This is the probability that they will not meet each other. Any doubts to anyone now? Please respond. So if this is the event which has happened in advance, then what is the probability that if the Naoki had been willing to wait for 15 more minutes, they could have meet up? Okay, they could have meet up if she have waited for 15 more minutes. So if we have waited for 15 more minutes, so I'll plot a graph for 15 more minutes. Okay, this is 15 and I'll say this is the 30. So if they have waited for 15 more minutes, so 15 more minutes, so I'll say this is the case. So if we waited, Nike waited for 15 4 minutes, so then that might be the cases here, isn't it? So now tell me one thing, what is the area of this green region? Okay, what is the area? Okay, will it be on x-axis, y-axis? It doesn't matter here. That's simply the nomenclature. You can take it on the x-axis, y-axis, okay. Now, so I can say the area of this green region. If we waited for 15 more minutes, so 15 and 15, I'll say here. Or you can take it on the, I have taken opposite side. Okay, you can change the axis. So half of 105 into 105 minus half of, if it is 15, this is 15, so this will be 90 and this will be 90. So minus half of 90 into 90. That is the area of the green regions. So the answer is equal to 13 by 90 if you solve this, and that is the answer. Any doubts, anyone? Please tell me. Or in the denominator, you can write down that this is equal to half of 105 into 105 plus half of 105 into 105. So this is also based on the conditional probability. Any doubts to anyone now in this question? Can I move to the next question? Try this, question number 19. Okay. Box 1, 4 by 7, right. That's correct. So box 1 contains one red ball and two white balls. So there is a first box 1. It has got one red and two white. Box 2. It has got two red and one white. One ball is drawn randomly from box 1 and then transferred to box 2. Then a ball is drawn randomly from box 2 and it is red. So this is the event which is happening in advance. So write down the first of all denominator. One ball is transferred from bag 1 to bag 2. So the ball which has been transferred from bag 1 to bag 2, either it can be red or white. So if I am transferring a red color ball, then the probability that I transfer red is equal to 1 by 3. Okay. And then in the bag 2, there will be 3 red and 1 white. So 3 red and 1 white. So to get a red one, the probability is nothing but that is 3 by 4 plus. So this is the transfer from red to red. I'm transferring red and then I'm getting red. Second, if I'm transferring white, so probability that I transfer white 2 by 3. So if I transfer one white from box 1 to box 2, there are two red, two white. So out of 4 balls, 2 of them are red. So probability of picking the red ball, that is 2 by 4. So white to red. So this is the event which has happened in advance. Then what is the probability that the transferred ball is white? So which part will come in the numerator, the first part or the second part? Because I need to take A intersection B. This is B and I need to write down A. Yes, that's right, second part. So in the numerator, you can write down that is 2 by 3 into 2 by 4. And the answer is equal to 4 by 7. And that's any doubt now to anyone? Is that clear? Siddhant, Aditi, Avinash, Bhumika, Garima, XAT, Jatin. Okay, so let's move to the next question. Try this question number 20. let's say there are four boxes. So box 1, box 2, box 3, and box 4. There are four boxes. Each contains two balls. The first box has a red and a white ball. The first one has red and white. The remaining three boxes each have two white balls. So white, 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 white. A ball is picked at random from box 1 and put in box 2. So from box 1 to box 2, one ball. Then a ball is picked at random from box 2, put in box 3. Then from box 3 to box 4, and then one ball is picked from box 4. The probability that the ball picked from the box 2 is red, given that the final ball picked from the box 4 is white. Okay, this is final box which I picked is white. Now tell me what are the different possibilities. From first to second, I am transferring what? Can I say there are two possibilities? Either I'll transfer red or I'll transfer white. Yes or no? So let's take I transfer red. Okay, I transfer red. And then I transfer red. So in this case, there is two white and one red. So there is two white and one red. So I am transferring now white. Then in the third box, all the three are white, so I need to transfer white. Now in the fourth box, all of them are white, so again I'll get white on. There is no other possibility. Is that part clear to all of you? Please respond. Now second case, from first to second I transferred red. And in box 2 there are two white and one red. So if there are two white and one red, so I can transfer red also. Now in the third box there are two white and one red. So two white and one red. So third to four I can transfer either white or I can transfer red. So that is again red, 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 and then finally getting white, finally getting white. Is that part clear to all of you? Okay. So if I'm transferring from first to second red, then there are three possibilities. If I transferred white from first to second, if I transferred white from first to second, then second to third also white because all the three are white. So I can only transfer white, white, and white. So from first to second, if you're transferring white, there is only one possibility. Any doubts to anyone now? Please tell me. Now let's find out the probability in all the four cases. Now what is the probability in the first case? Probability that red is transferred from first to second, that is half into. Now there is one red and two white. So one red, two white. So probability that I'll transfer white, so 2 by 3 into. Now in the box 3, all the three are white. If all the three are white, so probability of transferring white, that is 1. And in the box 4 also, all of them are white. So picking one white, that is also 1. So which is equal to 1 by 3. Any doubts to anyone for the first part, please tell me. Now for the second part, I am writing on the left hand side. I am transferring red. So probability that I'll transfer red, that is going to be equal to how much? 1 by 2. Now in the second bag there is two white and one red. Now again I am transferring red. So two white and one red and I am transferring this. So that is probability is how much? 1 by 3 into. Now in the third one, there is two white and one red. So two white and one red, but I am transferring white. So two white, one red, and I am transferring white. So the probability is 2 by 3. And then now in the fourth bag, all of them are white. So picking one white from all the three, the probability is 1. So is the second case clear to all of you? Please respond. Similarly, third case. One red, one white, I am transferring red. Probability is half. Now in the second bag, since I transferred red, there is two white and one red. So if I am transferring red from two white and one red, so from three balls, one of them is red and I am transferring red, that is 1 by 3 into. Now in the third bag, there is two white and one red and I am transferring red. So again 1 by 3 And in the last box, there is 2 white and 1 red. So probability of getting white, that is 2 by 3. This will be 1 by 27. I think the second part it will be equal to 1 by 9. Any doubts to anyone now? Please tell me. And in the last case, what is the probability that I'll transfer white from first to second? Half. Now in the second bag, all 3 are white. So if all 3 are white, so what is the probability of transferring white? 1. So into 1, which is equal to half. So what is the final answer? In the denominator, I'll get 1 by 3. There are 4 possibilities plus 1 by 9 plus 1 by 27 plus 1 by 2. And which part will it come in the numerator? It says, given that final ball picked is from box 4 is white, what is the probability that the ball transferred from bag to box 2 is of red color? So box 2 is of red color. Ball picked from the box 2 is of red color. So which one in case I need to write down in the numerator? These 2 cases. Yes or no? Red. From second, I'm taking red. These are the 2 cases. So in the numerator, it is going to be equal to 1 by 9 plus 1 by 27. Solve this, you'll get the answer as 8 by 53. And this is the answer. Any doubts to anyone? Clear to all of you how I have applied the conditional probability question? Panda here? Yes, m plus n is then 53 plus 8, you can add it. So can I move to the next question now? Try this. Important question, in fact. Assume that you are presented with 3 points. 2 of them are fair. So it means head and tail and head and tail. And other a counterfeit that always lets head. So the third coin, both the sides are head. You randomly pick one of the 3 coins. Now after this picking the coin, you flip it 3 times and observe that it lands head each time. So write down the denominator, the event which has happened in advance. It says you randomly pick one of the 3 coins. So what is the probability of picking any one coin at random? 1 by 3 into. And it has been flipped 3 times. And observe that it lands head each time. So if I pick the first coin, what is the probability of getting head in all the 3 occasions? Can you say half into half into half? Plus probability that I pick the second coin, that is 1 by 3. And getting head in all the 3 flips, that is 1 by 2 into 1 by 2 into 1 by 2. Plus probability that I pick the third coin, half 1 by 3. And getting head 1 into 1 into 1. Because both the coin sides are showing head. Now, if this is happening in the advance, then what is the probability that it is a coin with 2 heads? So, which part will come in the numerator out of these 3 parts? That's right, the third part. So, 1 by 3 into 1 into 1 into 1. Solve this, you'll get the answer as 4 by 5. Is that clear? Any doubt? Yes, Sole ka coin, you can say it. Alright guys, so let's move to the next slide then. Try this. Okay, 5 die are rolled. What is the probability that all 5 die roll a 6 if it is known that at least 4 of the die have rolled 6? Now, at least 4 of the die have rolled 6. So, which 4 dice? That is 5C4 into, and probability of getting 6, that is 1 by 6 is to power 4, and one of them is showing a number which is not this. So, that is 5 by 6. Is that part clear to all of you? It says at least 4 of the die have rolled 6. So, exactly 4 die have rolled 6 or all 5 have rolled 6. Let me write down step by step. At least 4 means 4 die, exactly 4 or plus exactly 5 die have rolled 6. Then what is the probability that all 5 die roll a 6? And in the numerator, it has to be exactly 5. Is this part clear to all of you? So out of 5 dice, 4 of them are showing 6. So which 4? 5C4. In all the 4 cases, the probability is 1 by 6. And in one cases, it is not showing 6, so it is 5 by 6. Plus, if all 5, so that is 5C5, into all of them are showing 1, or sorry, 6, so that is 1 by 6 is to power 5. And in the numerator also, it is 5C5 into 1 by 6 is to power 5. And this is the answer. Any doubts to anyone? Please respond, all of you. So can I move to the next question? Try this. A coin is tossed a total of 8 times if head appear at least 6 times. So if head appears 6 times, so what are the possibilities? The head will appear 6 head, or it will appear 7 times, or it will appear 8 times. what is the probability that head appears on exactly 7 passes? So in the numerator, 7. Is that part clear to all of you? Please respond yes or no. Now, so 6 head. So 8 times, so 8C6, on which 6 occasions we are getting head. And on these 6 occasions I am getting head, so probability of getting head is half. So 1 by 2 raised to power 6. And 2 of the cases I am getting tail, so 1 by 2 raised to power 2. Plus, if I am getting 7 heads, so 8C7 into 1 by 2 raised to power 7 into 1 by 2. And all the 8 of them are showing heads, so that is 8C8 into 1 by 2 raised to power 8. And in the numerator, it will be the middle part. 8C7 into 1 by 2 raised to power 7 into 1 by 2. And solve this, you'll get the answer. Any doubts to anyone now? So I hope that the funda of conditional probability is pretty much clear to all of you. So we'll stop here then. All right. And tomorrow I'll take the last part of the modern maths, that is Pigeonhole principle. Okay, a very important, it is used in the DILR section also, that particular concept. So, and it's a small lecture round of only of 1 hour, and we'll complete modern maths tomorrow. So if there is any doubt, please ask me. Yes, what is the doubt in a sphere question? देखो ना, अब एक स्फीयर है, अब स्फीयर के अंदर कोई पॉइंट लेना है, तो वो जो पॉइंट होगा वो वॉल्यूम पे होगा या सरफेस के ऊपर होगा? टेल मी निकिता, थिंक लॉजिकली. आई नीड टू टेक वन पॉइंट फ्रॉम द इंटीरियर ऑफ ए स्फीयर. अब एक बॉल ले लो, टेनिस बॉल. अब टेनिस बॉल पे जो अंदर का पार्ट है उसमें से मुझे एक पॉइंट लेना है, तो वॉल्यूम होगा ना, इट इज नॉट ए सरफेस एरिया. ओके, एनी अदर डाउट? Okay, now you guys should tell me, what should I start? Should I start with algebra or number system? 9 o'clock? Meher, 9 o'clock. Okay, guys. So,
Music.